Okay, hello everybody.
Hello, everyone.
Let me introduce myself. My name is Jamaluddin, Professor of Chemistry, Department of Natural Sciences, and I am Founding Director for Center for Nanotechnology, Coppin State University. President, Provost, Vice President, Interim Dean, Senate President, Department Chair, invited guest, STEM Day participant, panel of judges, ladies and gentlemen. Welcome to our first annual virtual online STEM Day 2020. The Center for Nanotechnology at Coppin State University has been at the forefront in preparing students for the workforce in the areas of engineering, mathematics, science, and technology. STEM Day at Coppin State University is an outreach program organized by the Center for Nanotechnology and sponsored by Constellation, an excellent company. The program provides the opportunity for middle and high school students to explore the exciting fields of STEM through demonstration, hands-on activities, and a science fair competition. But due to COVID-19 restriction, the program is being held virtually this year. We hope that the presentation will provide a framework for the broadening of interest and training in STEM-related fields. Coppin State University extends its sincerest appreciation and gratitude to Constellation for ongoing Energy to Educate E2 grant support to the Center for Nanotechnology. I would also like to acknowledge our IT department headed by Dr. Ahmed El Hagan for their support of all our online programs. Now, to all the students, good luck in your presentation. We strongly believe that this will be an important step of your educational career ahead of you. This is not only fun, it also motivates, encourages, and inspires young people like you to change tomorrow's world as future scientists. May we have a fulfilling and successful event. Now, I'd like to invite our Coppin State University President, Dr. Anthony Jenkins, for his welcome remarks. Dr. Jenkins, please.
Yes, Dr. Udin, thank you very much. It is a pleasure to be with you, and I hope that everyone is doing well and you and your family and loved ones are safe during these unextraordinary times that we find ourselves in. You know, I just want to say thank you to you and to our entire academic department, to the Department of Natural Science and the Center for Nanotechnology, to our provost, to our IT department. You all have put on another wonderful opportunity and program that not only showcases the best of our campus and our faculty, but it also continues to illustrate and connect the impact that Coppin State University is having across the city of Baltimore and the state of Maryland. And so to all of our students, I want to welcome you as well. Welcome you virtually to our beautiful campus, which unfortunately you do not get the opportunity to see in its full majestic fashion, but hopefully you will in the coming days. Also, you do not get the opportunity, unfortunately, to see our state-of-the-art Science Technology Center. It is amazing, and it will help provide all the academic and support needs that students like you and current students can take advantage of here at Coppin State University. Students, listen, I want to thank you for participating. I also want to wish you the best of luck on your presentations today. You are an important, invaluable asset to the growth of our city, our state, our nation, and our world. Your emotional intelligence, your intellectual strength, your diversity, and your curiosity are all the facets we need to help make every aspect of our world better. You are the problem solvers of tomorrow, the critical thinkers. You are the ones that are going to continue to move our society and our world forward. And I am so glad that you are partnering with us today to participate in this wonderful event. So with that, I will pause and say again, thank you, welcome for being here, and thank you for participating in this wonderful STEM Day virtual event. Doc, I'll turn it back over to you.
Okay, Dr. Jenkins, thank you so much for your great speech. Thank you. Now I would like to invite Dr. Luis, our Provost and VP of Academic Affairs, Coppin State University. Please, Dr. Luis.
Thank you, Dr. Uden. Thank you so much for this invitation. Hello, everyone, especially those students who are on this call. For me, every year, and I know this year we're virtual, but I've been to all the face-to-face ones since I've been back at Coppin, and it is extra special for me because as a teacher, I am just passionate about seeing youngsters learning new things. I am passionate about seeing individuals understanding and expanding their horizon as far as it relates to STEM. And so Dr. Uden and his team, Dr. Giroux, Dr. Gahn, it is such a great opportunity that you keep affording these students. And I've been in room 120 and I've seen students from all over the country, from all over the state who participate in this activity. And so I thank you for choosing Coppin State to help to build that foundation of opportunities in STEM. We need you. We need you to be the future, to not just be in the STEM field, but to lead STEM education. And I know for a fact, and I tell this all the time, I have a niece who graduated from the STEM program at Coppin, biology program at Coppin. And I can tell you that that experience provided her with a wealth of opportunities that she is so sought by all different companies. And she was admitted to College Park. She had an admissions letter to College Park. And I begged her, Coppin is the place to be. She came, she never regretted a moment of it. So for those of you middle school and high school students who are on this call, while I wish you all the best on your presentations today, this should not be the end of it. Let Coppin be your first choice to pursue a degree in STEM. We can provide you with the foundation you need that you can have the world open to you once you are through. We have the expertise, human expertise, we have the physical resources in our building, and we look forward to seeing you on campus where you can gain even greater experiences working with us. Thank you again for doing all of this, Dr. Uden and your team. Thank you, students, and I look forward to hearing some of the presentations. I always do, and this will not be different. Thank you.
Dr. Uden, you're muted. Dr. Uden, you're muted.
Dr. Uden, you're muted.
I'm sorry. Thank you so much, Dr. Luis, for your welcome remarks. Now I'd like to invite Dr. Michael Freeman, Vice President of Enrollment Management and Student Affairs. Dr. Freeman.
Good afternoon.
Good afternoon.
Thank you for inviting me to this important event. Every year I look forward to STEM Day. It's one of the big opportunities for us to showcase Coppin at its best, both in terms of our academics, but also, as President Jenkins said, our beautiful campus. I want to welcome all the students and parents and anyone else who's listening in to Eagle Nation. And in my little time, I want to tell you about being an Eagle. And I want to invite you to join us when it's your time to think about applying to colleges and universities. So, you know, eagles have fine vision. They can see up to 3 miles. This is similar to you all in terms of having the vision at this point to think about involving yourselves in STEM. Eagles are fearless. They don't back down to anyone. They're tenacious and they rise to greater heights. Eagles can fly higher than any other species of bird. And I want you to fact check me on this and look it up. When storms roll in, eagles fly high when other birds fly low and look for cover. That's what I want you to be. Eagles possess vitality. They morph over time. They change themselves to be a part of what's going on in their environment. And then finally, eagles nurture their young. And this is an important point because here at Coppin, that's exactly what we do. We nurture you while you're here. We develop your potential and we help you transform your life into something successful and positive for the remainder of your professional days. Again, I want to welcome you to Coppin State University, and I look forward to seeing you when you apply for admissions. Have a great day.
Thank you so much, Dr. Freeman. Now I'd like to request our interim dean, Dr. Curtis Charles. Are you there, Dr. Charles?
I am. Good afternoon.
Good afternoon.
Could you hear me? Could you hear me well?
Yes.
Yeah. I just wanted to, first of all, thank you for the invite and just wanted to welcome everyone that's here today. Just wanted to leave a couple of nuggets with you. I'm also a HBCU graduate. I'm also a graduate of MIT and Northwestern University and Morgan State University. And one of the things I wanted to challenge you with as you think about applying to grad school at Coppin is that the foundation that our faculty gives students makes them really marketable at any graduate program. That's the one thing I want you to do. There are several things that we do well at the HBCU, but one of the things we do well is to give you a foundation. The hardest thing for me in graduate school at MIT really wasn't the work. The hardest thing was the competitions. And from those of you guys who are from India on the call was your colleagues from IIT. Those are my challenges. But the foundation that you would get from an education as Coppin is something that you want to really consider very strongly, and we would provide that for you in the arts of sciences and education and the others. One of the things, the last thing I want to leave you with is be open.
Dr. Charles, I think you became muted somehow. To unmute yourself. There you go.
Thank you. What I want you to do, thank you so much, is to be open to different professions, even what you're studying, and that happens by taking different electives. I've been a university administrator for almost 25 years, but I've also worked at Microsoft. I've also worked at IBM. I've also worked as a VP for research and development for a Defense Department firm. So the more you keep yourself open, the more you keep flexible. The next thing is that there are about 37% of the world's technology jobs are unfilled right now. You are entering a STEM field that is going to make you very, very marketable. So just be open, collaborate across the spectrum. Try not to stay within your own department. Talk to the folks in arts, talk to the folks in dance, talk to the folks in English, but make sure that you embrace this opportunity, because the one thing I could assure you is that the education that you get at Coppin, you're going to be competitive wherever you go. Thank you so much.
Thank you so much, Dr. Charles. Now I'd like to invite my friend, Dr. Mintesinot Jiru, Chair, Natural Sciences. Dr. Jiru.
Dr. Giroux was having some problems getting in, so I'm still working with him. I'll let you know when he's on the call.
Dr. Jiru?
Like he just joined.
Dr. Jiru?
Dr. Uden, Kelly's working with Dr. Drew.
Oh, I see. Thank you.
Yes.
Thank you so much.
Hello?
Dr. Jiru?
I'm still working with him.
I think
if we can come back to him.
Okay, let's go to the another speaker. So I would like to request now our special guest here, Miss Carrie Stockwell, Corporate Relations Constellation. Miss Stockwell, please.
Thank you, Dr. Uden, and what a pleasure and a privilege to be here with everyone today. I'll be brief. I am representing Exelon and Constellation. If you're not familiar with us, we also have BGE as part of our company, and we are the largest clean energy provider in the United States, with a zero carbon factor, more than twice as much as any other energy provider. So we're very proud of that. And as part of what we do as a company, we also commit to giving back and encouraging future energy leaders, including in STEM. And Dr. Uden has just done a wonderful job over the years of providing this opportunity to, through Coppin State, to outreach to students. So I was inspired by Dr. Freeman's remarks about being an eagle. I'm going to take that with me in my heart as I go. And I think as you think about your future, those are just some gems to think about, to come through this challenge on the other side. I commend you, students. It's a Friday afternoon over the summer, and you've made the commitment to be here today to present, to learn from others. So I think you've already shown yourself to be an eagle. You are flying high while others might be trapped in the storm. You're focused, you're committed. I commend you for that, and I applaud you. So thank you, and I look forward to the presentation. Thanks for the opportunity.
Mrs. Stockwell, I would like to thank you so much. I know you're so busy, so you're giving us time. I know that you are working with nationwide. There are so many schools are getting help from that Energy to 80 grant. And good thing is that Coppin is only university, 2011 to until now, 9 years we got this grant. And thank you for your support. And I would like to thank you, Constellation, for your great support to us. Thank you so much.
Thank you.
Hello. We have sound, some sound. Okay, thank you so much. Please stay with us. Maybe I know you are busy, but we have a wonderful young scholars will present today. So we have a judges of panel also as well. Okay, next, what about Dr. Jiru? Our chair.
Almost there.
Almost there?
Okay. One moment.
Okay. If you are working, Kelly, then we can go for next one, and then Dr. Jiru can come. Is it okay?
Yes, you can move on.
Okay, so let me call my co-worker, Dr. William Gahn. He is working since 2015 in our center, Center for Nanotechnology, and then he will actually present very brief overview and research activities in our center. Dr. Gahn, please. William.
Dr. Gahn, you might be muted.
You muted?
Yeah.
Yes.
Okay, thank you, everyone. I'm Dr. Gan, and briefly, I want to share with you about our Center for Nanotechnology, Coppin State University. For those of you who have not as yet seen our beautiful campus, these are some of the buildings on our campus. And if you are ever in the area, I would encourage you to come and visit with us. That's our Science and Technology Center and other buildings in the school. So about Center for Nanotechnology, it was founded in the year 2007 by Dr. Jamal Woodin. We are actually located in the third floor of the Science and Technology building. What that you see on the left is a very beautiful building, and we have a number of these on campus. Our research is mainly on nanotechnology and renewable energy, and our students today are going to present their work on this area of research. Over the course of the years, we have had a number of students work in our lab, undergraduate students, as part, especially with natural science, as part of the requirement for graduation, they have to do a thesis work, and some of them just do a literature review, but the Center for Nanotechnology affords them the opportunity to do hands-on research and to write their thesis based on the work they have done. Also, we do have high school students who come to the lab over the summer, and then they get hands-on experience. I mean, thanks to Constellation that funds, this program. Each year we have high school students, that comes, they come to the Center for Nanotechnology, and then they do hands-on research. This year, we couldn't have the STEM day here, but that has been the culmination of the research over the summer, that it ends with a STEM day and also a science fair. So we host the STEM day and also other conferences here. This is our research team. We work with a number of people. As I said, Dr. Woodin as a founding director. We work with the chairman of the Natural Science Department, Dr. Jiro, in the area of nanofiltration, and Dr. Nasbet in the area of computational chemistry, Dr. Sobi in the area of organic synthesis, Dr. Chavez in the area of inorganic chemistry, and Dr. Providence in the area of computational chemistry. So we collaborate with so many scientists. These are those who are actually part of Coppin State University, but we do collaborate with other people. We have international collaboration and other national collaboration. We have so many students, as I said, who have passed through the center. So on the right, we have some of the undergrad students. Some have gone ahead to do graduate studies in STEM, and they are excelling, partly due to the experience they got here in the Center for Nanotechnology. Some also have gotten good paying jobs in the STEM field. So our research has been on dye-sensitized solar cell, terahertz research, gold nanoparticles, and a host of others. And we have so many publication, as I have on the right. So these are some of the things that we have been lucky to do here at the Center for Nanotechnology. These are some of the instrumentations that we have available to us. So with our Science and Technology Center, we do have the state-of-art instrumentation, such that you cannot even find in some, schools, in some universities, renowned universities in the country. We have the field emission scanning microscope, the transmission electron microscope. These are very huge instruments that are housed in their separate rooms, and they help us to do nanotechnology, because with nanotechnology, our samples, you cannot see them with your naked eye. So these instrumentation help us to do real chemistry. And we have others like Lifetime Instrument, DLS Instrument, Nanolog, and FTRR. So with our high school student and middle school student, as you think about college, think about COPing, because we have all these things which will really give you a very enriching undergraduate education. So with nanotechnology, as I said, our presenters are going to talk about these, so I will not spend too much time on this. Suffice me to say that nanoparticle, we are talking about dimensions of 1 to 100 nanometers, and examples are DNA, which has a diameter of 2 nanometer, and then also a buckyball. There are so many applications with nanotechnology, from defense to medicine to agriculture, and our participants presenters will share more light on this. Another big area of research is the renewable and non-renewable energy. So the energy we use can be classified to either renewable or non-renewable. So non-renewable is oil, coal, natural gas, nuclear energy. But with these come pollution, and also they are limited in supply. So there is a need for renewable energy. And some of these are solar energy, wind energy, hydro energy, and the others. And these are our research. These are the things we are trying to research about, and these are what our presenters are going to talk to you about today. In conclusion, I would want to acknowledge our president, Dr. Jenkins, our provost, our vice president, and all the important dignitaries who have come here to grace this occasion. We are so proud of you. It is a testament of your commitment to research and teaching in a STEM field. It will be very remiss of me if I do not acknowledge Dr. Diane Vaz. She has been very instrumental. She's really part of Center for Nanotechnology, and we thank her so much. We thank our judges, and also Ms. Kelly Jackson and her team. They have been phenomenal. Miss Melissa Rigby and all the IT staff, they have been very helpful. We thank you, faculty and staff, who made time off your heavy schedule to be with us. Thank you, parents, all our invited guests, and finally, our middle and high school students who are going to present today. I believe you're going to have a wonderful time. Thank you, and good luck in your presentation. Thank you very much for listening. Thank you.
Thank you, William. Thanks. I think you covered a lot. Anyway, so our chair, Dr. Jiru.
Can you hear me now?
Okay, you're ready. Okay, thank you. Please.
Sorry, sometimes in the digital world, the technology can be challenging,
I know.
But we made it. Thank you so very much for joining us, Dr. Jenkins and Dr. Lewis, and then every one of the cabinet members, faculty of the Department of Natural Sciences, and then our high school and middle school students. Welcome to this annual STEM Day. This STEM Day gets better and bigger every year. And we learn a lot from our experiences, and we expand on energy literacy a lot. So at the Center for Nanotechnology in the Department of Natural Sciences, there is a lot that's going on when it comes to energy literacy, especially with what is going on around us in the environment. Environmental crisis is something that we experience every day. See what is happening in Texas and then in the Gulf as we speak. In the previous years in Florida, Puerto Rico. So environmental crisis is really is the issue of the day for all of us. And the only way to get out of this crisis is when we educate ourselves and our high school students, college students in energy education, simply because much of the crisis is the result of the amount of fossil fuel that we use every day. I'm sure this is not new for anyone, but unless we move to renewable energy sources, unless we change the lifestyle in general, the crisis will get worse and not really better. So the effort that the department is putting forward and what the Center for Nanotechnology is doing every year is really to improve our energy efficiency. So far, with the results that we found, all the publications that the faculty is doing in the department, it is promising. It is really promising that we can actually change the course. This high school initiative really helps us nurture our high school students who are going to be future CAPIN students. The department nurtures from high school, and then hopefully we get them through our programs because our programs has proven to show success compared to other programs in the area. Undergraduate research is a requirement. It's not an option. And because of that, we have seen many of our graduates getting accepted to PhD programs without even going through a master's program. Many of our students going into pharmacy schools, into medical schools. This is simply because what we do is different. What we do is the right thing. We have diversified our curriculum in such a way that prerequisite courses are all infused into our curriculum, going into a med school, a pharmacy school, or any graduate program. So I would invite our future students really to join CAPIN, to join the Department of Natural Sciences to get the best education that prepares you not only for your undergraduate degree, but for your destination, where your destination being that medical school, that pharmacy school, or anywhere that you would like to be. That said, I would also like to take the opportunity to thank our administrators for the all-rounded support that you are really giving the department as well as the center. I would also like to appreciate my faculty, my team, who works tirelessly to really produce outstanding students in the Department of Natural Sciences. A plug here. Fall 2021 comes, our 2 new graduate programs will be online, will be there, set. I know Dr. Lewis is already preparing me for the defense or the presentation at MHEC. So we look very much forward to the success. So wishing you all the best, Dr. Udin, Dr. Gan, thank you for the outstanding job that you guys do. The support will always be for you. Thank you all the best.
Thank you so much, Dr. Jiru, for your opening remarks. Now our main items. Let's start. I think all the kids are waiting. So let me start the oral presentation. First of all, we divide 2 segments for middle school student presenters and high school student presenters. Okay. So there will be will be judges for that, judges list for middle school student. I'm just calling them. Dr. Muhammad Rabbani, Associate Professor of Chemistry, American International University, Bangladesh. Dr. Hani Sobi, Professor of Chemistry and Director of Organic Synthesis Center, Natural Sciences, Copenhagen State University. Dr. Emmanuel Eta Oving, Assistant Professor of Biology, Natural Sciences, Copenhagen State University. Dr. Samuel Azam, Postdoctoral Fellow, Institute of Nanobiotechnology, Johns Hopkins University. Dayan Kabir, Freshman, University of Maryland. And number 6, Faiza Sadneen, Freshman, University of Pennsylvania. I would like to talk about these 2 students. 2 students worked in this center, our center, 2 years, and they have publications. Now they're in UPenn and College Park. So they are now will be act as a judge panel with them. So these 6 people will panel judges list. So I would like to now introduce with the high school student presenters panel judges. There are 7. Dr. Arun Saha, Associate Professor of Physics, Department of Natural Sciences, Albany State, Georgia. Dr. Mobin Sheikh, Associate Professor of Chemistry, Indian Institute of Technology, Indore, India. I know midnight is there, so thank you so much. Dr. Monish Sarkar, Assistant Professor of Computer Science, Morgan State University. Dr. Faisal Islam Chaudhary, Associate Professor, Department of Chemistry, University of Chittagong, Bangladesh. Dr. A.H.M. Shamsud Joha, Assistant Professor, University of Technology and Innovations, University of Vasa, Finland. Dr. Raja Pandi, Associate Professor of Biology, Natural Sciences. Dr. Fred Nesbitt, Associate Professor of Chemistry, Natural Sciences. So all of you are panel judges for high school and middle school student. So now let's start the first middle school student. I would like to first to call Nabiha Rohim, please. Nabiha Rohim. And middle school judges, please be ready for judge her. Nabiha. Please show your slide presentation.
Yes.
And you have 6 minutes.
Can you see?
Yes.
Okay. Wait just a moment. Okay, so welcome to my presentation about solar energy. My name is Nabiha Rahim. I go to Eastside Middle School. I live in New York, and I am a rising 7th grader. So let's start with what is solar energy. Solar energy is energy received by the Earth from the sun. This energy is in the form of solar radiation, which makes producing solar electricity possible. So what is solar radiation? This is the energy that comes from the sun, which travels through the Earth in the form of light waves, known as electromagnetic spectrum. Electromagnetic spectrum is the term used by scientists to describe the entire range of light that exists in the world. They come in different forms, vibrate, travel, and have different lengths. So how do solar panels work? The first step is the sunlight hits the solar panels and generates an electric current, which is also known as DC. So in this diagram, you can see the sun's energy hitting the solar panels. And the solar panel transforms the sunlight into an electric current. So the second step is that an inverter converts the electricity from DC to an alternating current, AC. So in this picture, the red line would represent the DC current, and this is the inverter, which transforms the electric current to an alternating current. So the third step is that the AC powers your home while any extra electricity may be used by the grid. So here is just the diagram at a glance. So the sunlight hits the solar panels, transforms the sun's energy into a DC current, and then the inverter transforms the electric current into an alternating current, and then the AC is used for home consumption while any extra may be used on the grid. So now I will talk about the pros and cons of solar energy. So the first pro is that it is pollution-free. It's pollution-free and causes no greenhouse gases to be emitted after installation. The second pro is that it's a renewable energy source, meaning that it won't ever run out and it won't ever be in short of supply. We simply need just enough solar panels to capture it. The third pro is that it's better for the environment, which I will talk about later, and it improves humanity's health because it will make the air cleaner, which makes our lungs cleaner, and it's better for our health. So, however, there are also disadvantages of solar energy. One of them is cost, because the initial cost of purchasing a solar energy system is fairly high. The second is space, because you need a lot of space to put solar panels. And the third one is that it's weather dependent. The most important item you need with solar panels is the sun. So putting solar panels during the winter won't be as productive as it would in the summer. So here are some of the uses of solar energy. You can heat your swimming pool, you can heat your water, you can charge batteries, you can power your home, you can use it for cooking and even power fans. So why solar energy? Solar power systems derive clean and pure energy from the sun. Installing solar panels in your home can help combat greenhouse gas emissions. This reduces our collective dependence on fossil fuels, which is detrimental to the environment. When a fossil fuel is burned, they release carbon dioxide and other greenhouse gases, which in turn traps heat in our atmosphere, making them primary contributors to global warming. So what are greenhouse gases? Greenhouse gases are gases in the earth that trap heat. They let sunlight pass through the atmosphere but prevent heat that it brings from leaving. Main greenhouse gases are water vapor, carbon dioxide, methane, and ozone. They also contribute to global warming. The greenhouse effect is the process where gases in the Earth's atmosphere trap the sun's heat. So, as solar energy, a renewable form of energy. It's not. Can someone mute their microphone, whoever is not muted? So.
Okay, you're okay.
Renewable energy is made from resources that nature will replace, like wind, water, and sunshine. It is also called clean energy or green power because it doesn't pollute the air or the water. It can be continuously replenished and is never exhausted. So, here's a summary about solar energy. It provides clean, renewable energy. It reduces environmental pollution. It reduces our dependence on fossil fuels. It reduces greenhouse gas emissions, and it helps fight global warming. So thank you for watching. And does anyone have any questions?
Okay, thank you. Thank you for your presentation. So, middle school judge panel, please. You have 1 or 2 questions. You can ask, please. Anybody? Or raise your hand.
Okay, thank you very much, Nabiha Rahim. You presented very well. This is really surprising that as a 7th grade students, you know a lot about solar energy. So I have one question. Do you know what materials are used to harvest energy from sunlight?
Can you please repeat that?
Sorry? Do you know what materials are used to harvest energy from sunlight?
The materials that are used to harvest energy from the sunlight can be solar cells, which are known as semiconductors, I think.
Okay, that's good. That's good. Semiconductor material, solar panel or solar cells is the instrument, but there are some other materials like nanomaterials or nanocomposites, thin films, or some other nanotype materials. Thank you so much.
Thank you.
Okay, so you can ask, also post your question in the chat box if you want comments, anything. One more question we can go. Anybody?
Hi Nabiha, how are you? Great presentation.
Thank you.
Thank you. I just have one quick question for you. Have you ever thought about the efficiency, how efficient the solar panels are?
Yeah, so I would say that they're not that efficient because during the winter they wouldn't really be that productive because you need sunlight for them to work. But I think we should also use them more often because they're better than using fossil fuels, and fossil fuels are one of the biggest contributors to global warming. So I think using solar panels will be better to provide clean air for our community.
On the long term, that would be the future. Thank you very much, Nabiha. Appreciate it.
Thank you.
Okay, thank you so much, Navia, for your presentation. Next, let's go to the high school student, Samira Sadek, please.
Hi, my name is Samira Sadek, and I'm doing solar energy. I also go to Bridgewater Rainham Regional High School, and I'm in 9th grade. So what is a renewable energy? A renewable energy is an energy source that you can renew in a matter of time, so you don't have to worry about it running out. Renewable energies are also clean energy, so it's not harmful to the environment, and it causes things such as global warming. So you won't have to worry about renewable energy causing global warming or greenhouse gas emissions. There are also many types of renewable energy sources such as biomass, hydropower, geothermal energy, wind power, and solar energy. Solar energy is the energy source I will be talking about. So solar energy is generated from the sun in terms of the word solar, and the energy that is transmitted is either turned into thermal or electric energy. And the most common way people get the energy from the sun is by using solar panels. So here I have a picture of the solar panels, and inside every panel there are silicon cells, and there's also glass casing to protect the solar panels, a metal frame and wiring that is used to transfer the electric currents from the sun into the silicon. So when light hits the panel, it causes the silicons inside of them to move around, which inside of the silicons are electrons. So when the sun hits the silicon cells, it causes the electrons inside of the silicon cells to move around also, which causes a flow of electricity. So will we run out of materials to make solar panels? So basically solar panels are made out of silicon, silver, steel, glass, copper, and aluminum, and we won't run out because a lot of that is manufactured right now and a lot of it is abundant in the world right now. Also, this is how solar panels work. So the sun hits the solar panel, which converts the sunlight into direct currents, which they only go one way. And then it takes the direct currents to an inverter, which converts the direct currents into alternative currents, which alternative currents go two ways. And then you take the electricity your home requires, and then the rest of the electricity goes to the grids outside your home. The pros and cons to solar energy. So a pro is that the resource will not run out since the sun is abundant, and if you don't have the sun, you don't have life. It is also clean energy, meaning that it won't harm the environment, it won't cause greenhouse gas emissions while you're making energy from it. It also saves a lot of electricity bills. Cons to that is implanting the solar panel is expensive. It also takes up a lot of space. So if you want a solar panel in your home, it would take up a lot of space because you might have to implant it in your roof, and solar panels do come in many sizes, but if you want to implant it in your house, it could take up a lot of space. And weather also comes into action because if it snows a lot or rains a lot a week, it won't be as efficient because you won't get as much as energy. So how do we use solar panels? We turn the solar energy from the solar panels into heat, which is used to cook and heat up our homes. We also generate the electricity with solar cells or heat engines, and we also use solar powered calculators. And also, if you have ocean water, you know that there's salt in the ocean water, and we need to get the salt from the ocean water so we can use it. So solar energy dries up the ocean water, leaving us with salt. I thought of an idea for solar panels, so I noticed that we had solar-powered calculators. So in this model I drew, I thought of my idea of having solar-powered phones because a lot of people use phones in the world right now. So the solar-powered phones would work by placing a solar panel on top of your phone, which gets the sun's energy and converts it into electricity so your phone could charge without a charger. And also inside there would be a solar battery, so it could save up a lot of space. But if you don't want the solar powered phone, I noticed that a lot of companies such as Apple sells electric power, like charging phones, but they don't use renewable energy sources. So I thought of a solar powered phone case. So basically the sun would get the light and then it would convert it into electricity, which will charge your phone when you put it together. This will be convenient since you won't have a phone charger everywhere, so you could just charge it if you go to school or outside. And the statistic to my idea. So according to this website, it says that 44% of the world uses phones right now. So that would mean 3.5 billion people in the world uses phones. Say a phone charger takes about 2 to 6 watts per charge. So let's say if everyone on the earth just charges their phone, then that would mean 6.6 to 19.8 billion watts are used. That's just in one day. And that's a lot of energy we are using, and that's pretty bad for the environment. but imagine if we had solar-powered phones. We could save a lot of bills while using safe and renewable energy sources. Here's the statistic to the world. So Germany is leading in solar energy, and in 5th place is the United States. I feel like we should start using renewable energy or solar energy more because our country is bigger than Germany, and Germany's smaller, so they would like use less energy than us because we have more of a population in a bigger country. And in conclusion, so according to this website, it says that 914 kilowatts per energy is used by an average resident, and that's a lot. So most Americans don't use renewable energy sources as a way to get electricity. Instead, they rely on coal, oil, fossil fuels, and using electric energy generated from the sun is better for the environment, and you also don't have to worry about running out of resources. Therefore, I think solar energy is a very good alternative to non-renewable energy sources, and it is a good way to get electricity and thermal energy. That's all.
Thank you so much, Samira. Now our judges panel for high school. Please, we have 1-2 minute time, so please ask the question. Judges panel of high school students.
This is Fred Nesbitt. I have a question for Samira. I like your innovative idea. Have you thought about pursuing that for a patent?
I think.
Okay, any question?
Yeah, I have one question. May I ask?
Yes.
Okay, so Samira Sadek, would you please tell me what is the disadvantage of using silicon solar panel? Silicon-based solar panel. This is first generation solar cell.
I think like the disadvantages would be like the cost of implanting it, because it would be like more expensive, and like it would also take up a lot of space if you're trying to like put it in your house or like outside your house.
So how about biodegradability? So when you will discard it, will it not hazardous for our environment and earth?
I think like we should recycle it instead of like just disposing it, because if we recycle it, then we could renew it and use it for other things without like harming the environment.
Okay, thank you.
Any question? We have 1 minute time.
Hi, Samira. This is Raj.
Go ahead, Dr. Raj.
Yeah, it was a great idea, but my concern is she didn't explain how she's going to get it done. Particularly the solar panel on the telephone, on the phone.
I said that we could. So here's a phone. Like you could put the solar panel on top over here, so it could attract the light, and then we could also store a solar battery inside, so it could have a lot of like storage in, so you could save a lot of electricity. So when you charge it, it would automatically charge from the sun.
So how practical it is?
It could take like a lot of work to make it.
All right, thank you.
Okay, thank you so much, Samira, for your good presentation. Okay, let's go with now middle school. Afrin Mahmood, 7th grade. Afrin, please. You can put your any comments, please put your chat box.
Hi, I'm Afrin Mahmoud and I'm a 7th grader at Caucasian Middle School. And today I'll be doing a presentation on our renewable energy known as biofuel. Biofuel is mainly derived from biomass or biowaste. It is also known as agrifuel. The most important feature of biomass is that it is a renewable source of energy, unlike other natural resources like coal, petroleum, and even nuclear fuel. Some of the agricultural products that are especially grown to produce biofuels are switchgrass, soybeans and corn from the United States, sugar and sugarcane from Brazil, sugar beet and wheat from Europe, cassava and sorghum from China, miscanthus and palm oil from Asia, and jatropha from India. Biofuel, also known as agrifuel, is any fuel whose energy is obtained through a process of biological carbon fixation. Carbon fixation is a chemistry process that converts carbon dioxide into hydrocarbon molecules that would be found in a living organism. If this process occurs in a living organism, it is referred to as biological carbon fixation. There are three main types of biofuel: ethanol, which is often made from corn in the United States and sugarcane in Brazil, biodiesel made from vegetable oils and liquid animal fats, and biogas, which is made from methane derived from animal manure and other digested organic material. Most gasoline and diesel fuels in North America and Europe are blended with biofuel. Biodiesel accounts for about 3% of the German market and 0.15% of the US market. About 1 billion gallons of diesel are produced. Biodiesel is more popular in Europe. The US and Brazil produce 87% of the world's ethanol. Biomass energy can be converted into liquid biofuels generally in two methods. Method 1, sugar crops or starch are grown through the process of fermentation where ethanol is produced. And method 2, where plants are grown naturally to produce oils such as jatropha and algae. These oils are heated to reduce their viscosity, after which they are directly used as fuel for diesel engines. This oil can be further treated to produce biodiesel, which can be used for various purposes. Biofuels are nothing new. In fact, they've been around as long as cars have. Henry Ford originally designed the Model T to run on ethanol, and people have been running diesel engines on vegetable oil much longer than they have been running in diesel engines on petroleum-based diesel fuel. Rudolf Diesel, inventor of the diesel engine, originally designed it to run on vegetable oil. In fact, one of his earliest demonstrations at the World Exhibition in Paris in 1897 had a diesel engine running on peanut oil. Petroleum-based fuel originally won out over biofuel because of cost. The table is slowly turning, though, as fossil fuels become more expensive. They are renewable sources of energy, unlike other natural resources like coal, petroleum, and even nuclear fuel. Biofuel are the best way of reducing the emissions of the greenhouse gases. Energy density. Fossil fuels can carry enough energy in small enough spaces to make them very practical for a number of uses. Some disadvantages of biofuel are regional stability, food security, land use changes, impact on biodiversity, and global warming. In conclusion, biofuel is any type of renewable energy fuel which is derived from the process of biological carbon fixation. These are my resources, and thank you.
Thank you so much. So we'll take the questions now. Please, judges.
Okay, thank you, Afril Mahmood, for your nice presentation. I have one question. You have mentioned some advantages of biofuels over fossil fuels or something. So can you tell me what is the advantage of biofuel over fossil fuels?
Well, fossil fuels carry enough energy.
Sorry, I can't hear you.
We can't hear you.
So, Dr. Muhammad, I think you need to mute when the person is answering. We're hearing some noise from the background.
Okay, please repeat. What is the advantage of biofuels over fossil fuels?
Biofuels are they're a renewable source of energy, unlike fossil fuel. Hello?
Okay, we'll go another.
Okay, thank you.
Another judge?
I got a question.
Yes, please.
Afrin. So, Afrin, you said that biofuel can contribute to global warming. Do you want to explain a little bit on that? And the second thing is, what are your thoughts on growing food to produce bioenergy?
I'm sorry, can you repeat that?
The second question was, what are your thoughts on growing food like corn, sugarcane to produce energy?
What was the first question?
The first question was, how does bioenergy contribute to, you said one of the disadvantages in your slides was it causes global warming?
Yeah. Because the pollution of a lot of cars run on biofuel, and some of them they have more pollution, and it has an effect on global warming.
Okay, we are time up. So thank you. So our next high school presenter is Tanisha Khan, please. 9th grade. Tanisha. Tanisha, are you there? Hello, Tanisha.
I'm here, yes.
Yes, please.
Yeah, just give me a moment. All right. Oh my
Tanisha, we can't hear you.
How can you not hear me? Do I not have my mic on? Yeah, my mic is on. Okay.
Yes.
All right.
Speak loudly.
Yeah, just give me a moment.
Okay. That's good.
I
That's
know
good.
my computer is just not working for a bit. Just give me a moment.
Tanisha, you need to start because time is.
I said that my computer was not working.
Yes. Okay.
Okay.
Maybe we can move on to the next person.
No, I'm okay. I'm good now. I'm good now.
Okay, good.
All right. All right. Hello, my name is Tanisha Khan. I am an uprising 9th grader in Centennial High School, and I am presenting you today the use of gold nanoparticles for cancer diagnosis and therapy. Okay. Okay. All right. So first of all, with the key vocabulary words today, cancer is a disease caused by abnormal cell growth. According to the American Cancer Society in 2019, an estimated 1.76 million new cancer cases were diagnosed and more than 600,000 cancer deaths occurred in the United States. For a nanoparticle, according to the IUPAC, a nanoparticle is a particle that is between 1 and 100 nanometers in diameters. They can only be seen through an electron microscope. Because of a high potential in gold nanoparticles, it's increasingly used in cancer therapy. Many scientists refer to gold as the symbol AU, since it's part of the periodic table. So, anyway, shown in the image on the left, since gold nanoparticles are visible with optical microscope, a TEM and a high-resolution TEM are used to take a picture of a gold nanoparticle. While shown in the graph on the other side, based on the change of geometry or shape and size of the gold nanoparticles, they're able to bend the light, also known as shift the resonance wavelengths, to transform light into energy which can be exploited for cancer diagnosis and therapy. Why are gold nanoparticles so useful in the first place? Well, as I mentioned before, they show unique optical properties, meaning in response to light of a particular wavelength and radiation, they can be excited in ways that can be used for cancer photoimaging and phototherapy. Gold nanoparticles also have unique surface plasma resonance properties that allows it to bind easily with biomolecules. For example, DNA, protein, polymer, linker, a ligand, and captured drugs are shown doing so in the picture. The unique fluorescence properties of gold nanoparticles make it a good candidate for using in photoimaging. So, shown on the panel on the top left, chemotherapy is toxic for patients. Because not only does it destroy the cancer cells, but also the patient itself. But instead, if we if the chemo drug can be tagged with the gold nanoparticles and injected into the patient's body, it can pass through the blood vessels to the tumor sites and perform a targeted killing of the cancer. How do they recognize the cancer site? Well, a tumor usually secretes some growth factors that signal the development of blood vessels around the tumor so they can get nourishment and grow rapidly. Gold nanoparticles carrying their payload chase these growth factors and pass through the cells and unload their chemolating cargo and thus destroy the cancer cells. Shown on the figure on the panel on the right, in gold nanoparticles photodynamic therapy, first gold nanoparticles are injected into patients with reach to the tumor. After treating the tumor site with a particular wavelength of light, the tumor tissue, using its own oxygen, creates a reactive oxygen species, also known as ROS, that kills the cancer cells. Shown on the left bottom figure, a gold nanoparticle photothermal therapy is shown in a mouse carrying a human tumor. First, gold nanoparticles are injected into the mouse, which is then localized to the tumor. With a photoimaging technique, the site of the tumor carrying the gold nanoparticle is confirmed. Then, the near-red laser is applied, which increases the temperature of the gold nanoparticle, which in turn kills the tumor cell. All right, so here on the graph on the bar graph that's shown on the left, this is both of these are classical experiment published in British Journal of Radiology. Left-hand side figure shows the result of an experiment performed with a human prostate cancer in mice to see the effect of gold nanoparticles. While on the right-hand side figure is showing shows a mouse breast tumor treatment experiment where tumor-bearing mice were treated with control, which is no treatment. Gold nanoparticles only, radiation only, and gold nanoparticles combined with radiation. As you can see, both of these prove the same fact that gold nanoparticles plus radiation, when worked together, help not only increase the patient's life but also decrease the tumor volume. All right, so
you have 1 minute time.
Okay.
1 minute.
Okay, so skipping this is an example. The challenges of a gold nanoparticle in cancer therapy, even though it may be very useful, but there's still a lot of challenges to be met. For example, shown here, toxicity, activation of host immune response, size, biodistribution, retention time, and cost. Oh my god. That's, I don't know why I sent in. Okay. The slide there. In conclusion,
take your time. So you're okay?
I'll admit I'm a little stressed out by the technical difficulties I am having on my side of the screen. Anyway, so in conclusion, there are a lot of promising factors for gold nanoparticles. There have been some approaches that scientists have been able to find that are shown to be very useful. And thank you for, and here are my sources. Thank you for listening to me.
No problem. Thank you. You did good. Okay, so question and answer. from high school judges, please.
Hello, can you hear me?
Yes.
Hello, Tanisha. Thank you for your nice presentation. Okay, so if I assume you are the scientist of this area, so you presented this paper, this is your, let's say, keynote. So what can I take away out of your presentation? So as a scientist, what did you contribute here? Did you any, or you are proposing any?
So are you asking for, are you just asking for like a summary of what I've explained in the presentation, or?
Yeah, I am assuming you are the scientist of this presentation. Whatever is done, you are the scientist. Let's say you invented all of this. I understand that you are a high school graduate. Now, as a scientist of this contribution, if I want to take away something out of your presentation, what should I take away? What is the message?
The main message. Gold nanoparticle. Okay, the main message is, I guess you can say, gold nanoparticles, which are the main thing about them is that they're able to control the reflection of light. I mean, not they're able to bend light waves. Yeah. And that we scientists have found various ways to exploit them, and that in our future there's a chance we'll be able to actually use it in the clinical system to help with cancer.
Okay. Okay.
Okay, so thank you so much, Tanisha. Let's go to the middle school student, Rodoshi Bari. Rodoshi.
Good afternoon, my honorable judges. My name is Rochi Barch. I'm from Sedbrook Magna Middle School, and I'm going to grade 7. Today, I'm going to present renewable energy, wind power. Wind power is power obtained by harnessing the energy of the wind. It is a clean, renewable, and sustainable source. I think wind energy is the best alternative to produce electricity because it has bigger benefits and smaller disadvantages than solar and hydropower. It is also better for the environment than fossil fuels. The simplest designs are made of 3 main parts: the rotor blades, the nozzle, and the tower. As you can see in the diagram, the rotor blades look like plane turbines. They're flat but slightly curved to get maximum wind speeds. The nozzle, which is right here, has sets of generators and gears that speed the rotation of the blades and convert wind into electricity. The tower holds everything together at an ideal height. How it operates. The wind makes the blades turn, which is kinetic energy. The blades turns a shaft, which turns a nozzle.
What happened? You're okay?
Yes, sorry, it accidentally got out.
Okay.
How it operates. The wind makes the blades turn, which is kinetic energy. The blades turn a shaft, which turns a generator. The generator converts the kinetic energy into electricity. A transformer converts it to the right voltage, and it is exported to the electricity grid for everyone to use. There are many benefits of wind power. First, it's cost effective. It's a really cheap alternative, costing 1 to 2 cents per kilowatt an hour. It is cheaper than solar, hydropower, and also fossil fuels. It's a clean fuel source. It doesn't produce atmospheric emissions that are harmful to the environment and can cause acid rain, smog, and greenhouse gases. As you can see in this diagram labeled Wind Generation in 2013 provided a range of environmental benefits. It shows that carbon dioxide, sulfur dioxide, nitrous oxide, and water consumption have been greatly reduced. It also creates jobs. The U.S. wind sector employs more than 100,000 workers, and a wind turbine technician is one of the fastest growing American jobs. This is also good for the economy because of how many people might get jobs. Though there are many benefits, there are some slight disadvantages. It can impact wildlife. Flying species such as birds and bats can get killed running into the blades. Also, it can take up space from animal habitat. Far away from cities, you can't build a wind turbine in your backyard or in the middle of a remote city. Therefore, they must be built on a wind farm. Sometimes the distance can be pretty large. Noisy and unpleasant. As you can see in this diagram, how loud is a wind turbine? It shows that one wind turbine can be pretty loud, which imagine triple the sound because there's more than one wind turbine. It would be excruciating. However, many people don't live near the wind farms. It's an isolated area, so it doesn't affect many people. Wind energy is constantly developing. Though there are some slight disadvantages, there are bigger benefits. We can agree that it is key to reduce greenhouse gases and help our environment. It is better than solar and hydropower because it is more efficient. It is reliable and everlasting. We should choose wind power. Thank you for watching.
Thank you, Radushi. Okay. Question and answer from judges, please.
Hello, hi, Ms. Perry. This is Dr. Sobi. It's a great presentation. Thank you for presentation today. I just have one question for you. What do you think that to make wind power more applicable?
What do you mean by applicable?
To make it more more available, because right now it contributes to very small amount of the renewable energy sources. And what should we do to make it more available for us, to use if we would like to use it, for example, in Maryland, where would be or in any other state, where would be the best place to have it?
So I think you have to make the wind turbines a bit smaller so it doesn't take up too much land space. Especially in Maryland, I'm not sure if there's that much land to spare. So if the wind turbines were a bit smaller, we could apply it to Maryland.
Excellent, excellent, very good. Thank you.
Wonderful, wonderful, Dr. Sobi. Is there one more question I can take?
Okay, thank you.
I'm sorry.
Please proceed.
Okay, I'll take the Diane. Diane, please.
I just thought the presentation was really good. It was very informative about wind power, but just a suggestion in terms of the disadvantage of it, wind isn't necessarily a very constant form of energy. So a drawback is that it's not constant. So generally, what is your input about that? If you were to have find a suitable area where the wind is constant as opposed to solar energy where direct sunlight hits. So in terms of its comparativeness to other forms of renewable energy, how do you feel it compares, and how can you make it more applicable like Dr. Sobi had mentioned?
So, what's the question? Is it that, what's the question? Can you repeat the question again?
So generally, I'm just asking about the potential for it being a disadvantage where wind power is just simply not constant. So I just want to know your comment on that.
Okay, so since there's still
wind speeds vary, so.
Yeah, so I would say that you have to do some research and find an area that has constant winds, but also they should try to have some type of storage, so they could store extra energy, especially if it's a really windy day. They could store some extra electricity just in case there's a day where it's not that windy, and they can apply that energy.
And I can elaborate on this too. following what Ms. Berry just said, another alternative to this, like for what she say, is we can also like looking at the transformers that store like more storing. And another recommendation that's done by the Department of Energy is to have the wind power in high areas. Normally, like high areas have like can expose more to winds. So if you're living in an area that's like up ground, the visibility of having it as a wind like windmills and wind power will be more efficient.
Okay, thank you so much, Rodashi. Thank you so much, Rodashi. Let's go to the high school student, Hannah Seether, 11th grader. Hannah?
Yep.
Please.
Good evening. My name is Hannah Seether, and I'm an 11th grader at Mercy High School. Today, I'm going to be talking to you about biofuels. So in order to get most of the energy that we have today, we use fossil fuels. Fossil fuels are very popular, and they currently account for 85% of our energy needs. However, they are formed over the course of millions of years. This means that they are a non-renewable resource, and they will eventually run out. There are also numerous disadvantages to burning fossil fuels. For example, it emits a large amount of carbon dioxide. Carbon dioxide is a greenhouse gas, and it is a major contributor to global warming. The burning of fossil fuels also releases other air pollutants such as sulfur dioxides and nitrogen oxides, which can be detrimental for wildlife. So in order to solve this problem, we can use renewable energy. Renewable energy are energy sources that can be replenished. It reduces the dependence that we have on fossil fuels. It also produces less pollution, which means it creates cleaner air for those with asthma and breathing problems. Examples of common renewable energy sources are wind, solar, hydroelectric, and biofuels. What is a biofuel? A biofuel is a liquid fuel derived from biomass. Biomass refers to all organic material from living matter, and there are numerous advantages for biofuels. For example, it's sustainable and renewable. It is also less combustible than regular diesel, which means it's safer for us to use. Biofuels are also better for a car's engine. For example, it provides greater lubrication and less particulate deposits. The use of biofuels means that we will be using fossil fuels less. For example, there could be a 50 to 70% reduction in carbon dioxide emissions if we use biofuels instead of fossil fuels to power our cars. Another advantage of biofuels is that it can boost the economy. For example, it can create more job opportunities. Biofuels are grouped into 3 categories based on the type of feedstock that is used to produce them. A feedstock is a raw material or biomass that is used to create a biofuel. Examples of common feedstocks include agricultural wastes, crops, or grass, and even leftover cooking oil can be used to create biofuels. The 3 types of biofuels are first-generation biofuels, which come from food crops, second-generation biofuels, which come from cellulosic plant material, and third-generation biofuels from lipids in algae or cyanobacteria. So in this picture here on the right, you can see an example of a feedstock used for biofuel, and here is an example of a third-generation biofuel from the lipids in algae or cyanobacteria. The most common biofuel used today is ethanol, and ethanol is an alcohol-based fuel, and it's made from sugars found in food crops such as corn, sorghum, and barley. The most common food crop used today is corn because of its abundance and its cheap price. Ethanol is produced through a process called fermentation. Fermentation is a breakdown of sugars using bacteria or yeasts. So in order to create ethanol, A starch in feedstock, like corn, is then fermented to create a sugar. Then the sugar can be fermented to create an alcohol. However, there are also numerous disadvantages to using ethanol. For example, it uses valuable land that could be used for growing food to feed people. And this is a pretty big problem, especially as world hunger is rising, and we need the land in order to grow crops to feed people. So what's the solution to this? We can use third-generation biofuels, such as algae and cyanobacteria. Algae and cyanobacteria are sustainable, and they are non-competitive. They can also be used for biofuel production. Algae and cyanobacteria are photosynthetic, which means they convert light into chemical energy. Then the chemical energy that is created through the process of photosynthesis is then stored in the lipids of the cell wall. And lipids is one of the 4 major macromolecules, and it can be used and it can be harvested for energy. Another advantage of algae and cyanobacteria is that it produces more lipids per acre than typical land plants, and it can potentially produce 2 to 20 times more oil per acre. On the picture in the top right, you can see 3 types of cyanobacteria, and on the picture on the bottom, you can see lipids that come from algae or cyanobacteria. So what are the benefits of algae and cyanobacteria? Its growth is easy and efficient. It does not need a lot of light to grow, and it can be grown in an optimal temperature of 28 degrees Celsius. It can also be grown much faster than typical land plants. For example, plants like corn might take a long time to grow, but algae and cyanobacteria can be cultivated in just 7 to 10 days. It's a carbon-neutral fuel source, so it will remove carbon dioxide out of the atmosphere and put oxygen back in. And this is a benefit in factories where carbon dioxide is released. If there's an algae pond right next to the factory, it'll absorb that carbon dioxide, which is beneficial for the atmosphere. It's also very versatile, and it can grow in a variety of conditions such as seawater and freshwater. So how is biodiesel made? First, the energy-rich lipids are converted to a biodiesel. The oil is extracted by breaking down the cell wall, and this is done through the use of solvents or sound waves through the process of sonification. The extracted lipids then go through a process known as transesterification. In this process, fats and oils are broken down into fatty acid methyl esters. The oils react with alcohol and a catalyst in order to form biodiesel and glycerin as a byproduct. And glycerin is a common household ingredient in many household products such as soap. In the picture here on the top right, you can see extracted lipids, and in the picture on the bottom, you can see a biofuel after it has gone through the process of transesterification. So in order to large-scale produce this, the algae or cyanobacteria is mass-produced in open or closed ponds. Then the lipids are extracted. Then the fuel is produced at a biodiesel plant, such as the one shown here. Then it's sent to the American Society for Testing Materials, and this society tests the integrity of the oils that are produced. Then the fuel can be used to run cars, trucks, and buses. So in conclusion, renewable energy is the future of clean and green air for our atmosphere. It can reduce our consumption of fossil fuels and reduce the amount of harmful carbon dioxide we put into the atmosphere. It's carbon neutral, and it can lower the greenhouse gases. Biofuels are sustainable, it does not use valuable land, and it's easy and efficient. And this will be better for running this is a better source of fuel for the cars, trucks, and buses. Here are some sources that I've used. Thank you.
Thank you so much. Okay, question please. 1 or 2 questions, please.
This is Raj. Hannah, thank you very much for a clear presentation. I liked it very much. So my question is, what is new here? You know that based on your resources, there are so many scientists, so many biotech companies have been working on this for many, many years. What is new? What is your new kind of idea here? Are you proposing any new idea here?
A new idea is that we can explore different types of biofuels from different sources like algae and cyanobacteria. There are many different types of them, and we can grow them in remote locations where maybe there isn't a lot of land available, and since they don't take a lot of land to produce them, we could grow them in areas where there's not a lot of land, and that can be used for running cars and trucks.
Thank you.
Okay, so I have to go next presenter. Thank you so much, Hannah. Let's go to the middle school student, Jimran Hussain. Jimran. Hello.
Oh, yes, I'm here.
Okay.
And I'm going to show you my presentation. Okay. So I'm Zimran Hussain. I'm from Valley View Junior High, and I'm in 8th grade. And this is my solar plant heater. Now imagine a plant heater that is made of environmental friendly items that can grow plants faster and that can keep a plant through fall and winter. My hypothesis is the cost of my solar heater is less than a traditional greenhouse. The concept is a reflector that is used to reflect UV light into the cover into the aluminum foil that will reflect and absorb the heat into the plant, and the cover will be used for retaining the heat so that it can keep it for longer time for the plant to use the heat energy. And the cup holder is used for like putting the cup holder, and then you can use it for watering. And I put references to where I got my information from. And these are the model pictures of the solar oven I built out of cardboard, plastic bag, aluminum foil, and paper with tape and scissors. We're going to be for the cost analysis, we're going to be comparing my project to a traditional greenhouse. And the size of the house, both will be 5 feet by 5 by 5 by 2 feet. And the life cycle will be 10 years. This information here is for 5 years. The construction cost is, for the construction cost option 1, $30 plus $30 equals $60. The $30 is for like labor in 5 years. And with my project, you have to use aluminum foil, cardboard, super glue, etc. And labor will be $15 an hour, and it'll take 2 hours, and that's $30. The traditional greenhouse will cost $625, since $25 per square feet, and we're doing 5 by 5 feet on like this, base plate. And all this information is for 10 years. The construction of my solar oven will only cost $30 to make. Option 2 will cost $625. Yeah, we got it. And operation and maintenance, if you want to fix by yourself, you have to pay $24.80. And that's for 5 years, and for 10 years that's $49.60 or $60 for the labor. And for the traditional greenhouse, that costs $96.20. And total cost is, for my solar oven, is $79.60 to $90. And for the traditional greenhouse, it's $721.20. So the solar oven is like almost 90% cheaper than the traditional greenhouse. Benefits: the solar oven requires no electricity. It's easy to make and improve. It keeps plants safe from wind. It's portable. It's very cheap to make. Stuff made from recyclable materials, and it can help prevent large landfills. So my conclusions. My hypothesis is true. A solar oven is cheaper than a greenhouse. And this project is able to get the job done while being cheap, reliable, and easy to improve, and will might help bring an end to 2 million tons of landfill that's of cardboard. Overall, my project might be a masterpiece made from a simple design. And by the way, these models I made from Tinkercad, which is like where you can build like 3D models out of blocks. And these are my references. I appreciate the STEM Day organizer, Jamal Udin, and I thank you all, students and organizers, professors, and everyone for listening.
Thank you, Jimran. Any questions for Jimran, please?
Okay, thank you, Jimran. So far we have seen one project. He has already prepared something. So I have one question. So you say this is different from common solar greenhouse, right?
Yeah.
So how did you trap solar energy?
So basically, we trap the solar oven using aluminum foil, and we retain the heat and keep it in for a bit before it goes out, and the plant will be able to use the solar energy, and also infrared radiation from infrared light, because when it gets hot, it turns into infrared light, because in solar ovens, UV, because my project looks like a solar oven, and solar oven does the same thing. So with infrared light and infrared radiation, the plant will be able to grow faster and take less time to bloom into a flower. So I don't.
Okay, keep going.
So I'm not sure if it's necessarily trapping. It's just, helping the plant.
No, it's okay. So, but aluminum foil. So, can it absorb heat energy and radiate for a long time?
Well, yes, it does absorb. It does. Well, yes, aluminum foil does absorb heat, because if you wrap the aluminum foil in potato and put it in a microwave, the first thing that will get hot is actually the aluminum foil, because aluminum foil is actually a great conductor of heat.
Okay, thank you.
All right.
Okay, I'll take one more question. Okay.
I have a question for Jimran. It seems like you will be a very, great businessman. You have a very good cost analysis, huh? Very good cost benefit analysis. That part is wonderful. The question is, on your device and traditional devices, did you do any comparative analysis among their efficiencies? Let's say how efficient your one compared to the traditional devices?
Well, efficiency.
Mm-hmm.
Well, cardboard. Although yes, you will have an impact on something, since cardboard is made from industrial stuff, and so is greenhouse. But you see, so the reason it's efficient, because greenhouses, they actually use electricity and light to make the plants grow faster, and that requires an electricity bill. And since electricity requires lots of materials, and my solar oven doesn't require nearly as much, so basically my solar oven just only uses the solar energy, like from the sun. So my solar oven is actually probably more efficient than a traditional greenhouse. That's like even the same size.
Yeah, you're saying probably. Now let's say you're a scientist, right? Little scientist. Yeah. So you need to talk based on your evidence. Let's say you got a new device. It's cheap. but why should I buy the cheap one if it does not do the trick? You see what I mean?
Well, this is only the model.
I know.
The real project will be 5 feet, 5 by 5 by 2 feet, which means
Okay.
it'll be much bigger, much bigger, and it'll be able to fit lots of plants.
Okay, I'm sorry to interrupt you guys. I think it's fine. Thank you. So we have to go another presenter because of time restriction.
Thank you. Thank you.
Okay, next presenter is high school student Sajid Mahmood. Sajid
Mahmood.
Please mute. Okay, Sajid.
Okay.
Sajid, are you there?
Yeah, I'm here.
Okay.
Let me just do it. Okay. So, do you see the screen?
Yes.
Okay. My name is Sajid Mahmood, and today my presentation will be about renewable energy and solar power. And I'm a rising 9th grader that's going into Mount Hebron High School. So, when it comes to energy, there's two main types. There's non-renewable energy and there's renewable energy. So, what is non-renewable energy? Non-renewable energy comes from sources that will run out or will not be replenished for thousands or even millions of years. And non-renewable energy mainly consists of coal, oil, and natural gas. And as you can see from the chart to the right, coal, oil, and gas take up the majority of the energy used in the entire world as of 2019. They take up around 80% of the energy used, and the rest of the energy here, biofuels and waste, hydroelectricity, nuclear, these are all renewable energy. So here are some problems with non-renewable energy. The biggest problem with non-renewable energy is that carbon dioxide and other gases are produced when burning coal and fossil fuels. And as you can see from the chart, carbon dioxide, methane, nitrous oxide, and F gases are released into the atmosphere when using non-renewable energy. And these gases are very harmful to the environment as they contribute to greenhouse gases. They contribute to big problems like temperature rising, ocean waters rising, ice melting in the Arctics, more severe storms and more hurricanes, and more droughts and more heat waves. And as of now, there's currently a natural disaster that's going on in California. A wildfire is currently happening in Northern California, and this is a result of global warming. And it also affects us humans. Approximately 12,000 coal workers die in the USA from the toxic atmosphere when they're mining the coal. And non-renewable energy will not last long, and it will eventually run out. And that's why we'll be focusing on renewable energy. So what is renewable energy? Renewable energy is energy collected from renewable sources that are naturally replenished on a human timescale. And the good thing about renewable energy is that it is clean and 100% environmental friendly, unlike non-renewable energy where it is not environmental friendly. And some examples of renewables are solar power, wind power, hydroelectricity, and geothermal energy. Around 50 nations started using at least 50% of the energy renewable, like Germany and China, while the USA only uses 17%. And Iceland and Norway are the leading countries in renewable energy, where they use 99% of the energy renewable, and this is because they have a geological advantage, and they mainly rely on geothermal energy and hydroelectricity. So, what is solar energy? Solar energy is basically energy captured from the sun, which is then converted to electricity. There's two main types of solar energy, photovoltaic and solar thermal. And as for this presentation, I'll mainly be focusing on photovoltaic solar energy. So photovoltaic solar energy, which directly converts sunlight into electricity using panels made of semiconductor cells. Solar thermal technology is a little different. It captures the sun heat and then it uses that heat to heat up water. And solar thermal technology is normally used to heat up water. And the USA uses 1% of the energy, solar energy. So how does solar energy work? The way solar energy works is actually really simple. Solar panels absorb sunlight with multiple photovoltaic cells, which then generate electricity. Then the wire brings electricity to the inverter, where the electricity is converted from direct current to alternate current. Direct current is a current that goes in one direction, while alternate current is a current that goes in multiple directions. And alternate current is better because it is more efficient and it contains higher voltages of electricity. And any leftover electricity that's not needed will go to the meter and to the utility service. So, as everyone knows, everything in this world has some problems with it, and that also applies to solar power. The initial cost of buying solar panels normally costs around $25,000, which is expensive for many people. And solar panels aren't as efficient as many other renewables are. They can easily get damaged by many things like hail and broken branches. And the biggest problem with solar power is that market entry. It is really hard to compete with well-established energy industries, as for the past 200 years, we have been using non-renewable energy. We've been using coal, oil, and gas for a very long time. And that's why the non-renewable energy industry is so big, while the renewable energy industry is so small and not as rich as the non-renewable energy industry. And the process of making solar panels causes some pollution. For example, when they're making the batteries, they do emit some toxins into the atmosphere. And here's my conclusion. Our goal is to replace carbon-intensive energy sources like gas, coal, and oil, and to significantly reduce global warming emissions. The goal of a Paris Climate Accord is to reduce greenhouse gas emissions by at least 40% of 2030. The Paris Climate Accord is an agreement that was signed in 2016, that was signed by 80 countries. And if we start to use renewable energy, then we will see a big improvement in public health by preventing air and water pollution. And this also offers the opportunity to use renewable energy sources and preserve the non-renewable energy sources when if we ever have to use non-renewable energy sources. And even though there are some challenges to renewable energy technologies, as we progress through the future, we will be able to overcome these challenges with the advancement of technologies, widespread usage, and attention from world leaders and policymakers. So here's some facts on solar energy. Alexander Backrod discovered the photovoltaic effect in 1839, which is the effect that converts sunlight into electricity. Russell Oak created the first photovoltaic cell in 1941, and Bell Laboratories invented the first solar panel in 1954, and they also invented this first solar-powered radio in 1954. And the good thing is that over 2 million solar panel systems have been installed in the USA alone, and as from the year 2000, this is a 200% increase. And the most efficient solar panels are made from monocrystalline silicon, a high-quality semiconductor material. And California generates the most solar energy in the United States, with 17,500 megawatts as the capacity. And at around 1,000 acres, the world's largest solar power plant is located in the Mojave Desert in California. And Amazon and many other companies have launched many renewable projects. And for Amazon, they launched 3 renewable projects in 2019. And their goal is to get the USA to use at least 80% of their energy renewable by 2024. So thank you for listening to my presentation, and I hope you enjoyed it.
Thank you so much. I will take your 1 or 2 questions, please.
Yeah.
Judges.
Hello. Thank you, Sajid, for your nice and informative presentation. I have one question. Irrespective of environmental factors, if we do not consider the environmental factor, what other disadvantages of using non-renewable source of energy? That means if the one you are addressing that the environmental factor for using non-renewable source of energy is the main, but what other disadvantages of using non-renewable sources?
So there aren't many.
Why do we need renewable energy if we don't consider the environmental factor? What other factors can guide you to use the renewable energy?
Non-renewable energy is not as efficient as renewable energy, as
but it is cheaper.
Yeah, it's cheaper
and available. But
it's cheaper and you can easily find it in many places, like oil and gas.
But if you think that after 50 years or after 100 years, what will be the non-renewable source of energy? After 50 years or 80 years, what will be the scenario of the non-renewable energy source?
It would be
oil and gas.
As because non-renewable energy, they will eventually run out. So in the next 50 or 80 years, we will see like a decline in them, and they may even run out by then.
Thank you.
Okay, Sajid, thank you so much for your presentation. Let's go to the middle school student. You read Shahar. You read. You read. Are you there?
Yes, one moment, please.
Yes, please.
Okay.
Okay, go ahead.
Okay. Good afternoon. My name is Yurid Shahar Rahman, and I'm a 7th grader in Bayan Academy and Al Rahma Quran Academy. The principles of solar energy. To start off, an introduction on solar energy. Solar energy is energy generated from sunlight. Here I explain how solar energy works. An electric device called a photovoltaic cell converts sunlight into solar energy. The solar panels use photons to convert direct current electricity into alternating current, therefore generating electricity. So here's a little picture of how it works. So as you can see, the sunlight is the solar panel, which generates the DC and then converts it into AC, and then it becomes electricity. So here are some uses for solar energy that in daily life, like it powers fans, it can heat swimming pools, and etc. So solar energy is good because it uses renewable energy. Renewable energy comes from renewable sources, and you can use it over and over again. So here's a little picture of solar panels, which sunlight hits them. And then here are some benefits for solar energy. So it's renewable, like I said in the last slide, and it does not cause pollution or harmful greenhouse gases, and it's clean energy. And some disadvantages: it's kind of expensive to implant, and it's less efficient. So in winter, it won't work as good, and when it's not much sunlight is hitting it. And then this is my future recommendation for bringing up solar energy, so advertising it and helping people who don't have access to electricity, and it would also benefit them in a harmless way. So in conclusion, I think solar energy is great, it's beneficial, it's harmless, and it's the obvious choice. And that is my project on solar energy. Here's some sources. So images and materials and sources. And thank you for watching.
Thank you. Thank you. You read any question, please? Middle school judges, please.
That's a quick presentation, Yurid.
Yeah, I like that.
We have more time to ask you questions now.
Yes.
All right. So yeah, in your solar energy, I have a lemon question. Let's say it's a windy day or it's a rainy day. For days there is no sun. Then if you depend only on solar energy at your home, you will have no light, no electricity. How will you survive?
So if it rains, you could use another energy source.
Well, is there any way that I can use the same solar source for those days?
You can use it in like clear days where it's super sunny.
How about the windy or cloudy days or rainy days? Can I use the same solar system for those days?
I don't think so, because like then sunlight will hit it.
Okay, think of there are options. Think of a system that can store that energy for those days for you. Okay.
Okay.
Right.
Thank you. Thank you. Any question? One more question I can take before I go next one.
Thank you, Urid. As a student of 7th grade, your thinking is appreciated. At your level, you are thinking about renewable energy. This is really appreciating. Okay, so I have one question. Your title is the principle of solar energy, right?
Yes.
It means how a solar panel works. So, but
Yeah.
you missed what materials and what is the mechanism of harvesting energy or producing electricity. Do you have any idea about how it actually converts sunlight or solar energy into electrical energy?
So I think that when the sunlight hits the solar panel, it uses photons, and then it basically converts direct current into alternating current, and then it uses an inverter to generate electricity.
So I want to know this point. It converts solar energy into DC current. How?
It uses photons in the solar panel in the electric.
Photon is solar energy.
Yeah.
Okay, so how it converts photon into DC current?
It uses an inverter in the solar panel.
Okay, anyway, so you performed very well. Thank you very much.
It's okay. Thank you so much. Let's go to the next presenter, Afreen Reza.
Yeah, let me just share my screen.
No problem.
Can you guys see it?
Yes.
Okay. Hi, my name is Afreen Reza. I'm in 10th grade at Wooten High School, and today I'll be talking about nanotechnology and in specific gold nanoparticles. So I guess first I should tell you what nanotechnology is in case you don't know. So nanotechnology is the science, engineering, and technology conducted at a nanoscale that is measured in nanometers. It has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger amounts of information. Using nanotechnology, materials can be made effectively stronger, lighter, and more durable. And now many commercial products are on the market and in daily use that rely on nanoscale materials and processes. So there are many different types of nanoparticles, such as carbon-based, ceramic, and metal nanoparticles. And nanoparticles are made by breaking down larger particles or something called controlled assembly, which is man-made nanostructures. Under metallic nanoparticles, there are three major types, which are gold, silver, and iron. And today I'll just be talking about gold nanoparticles. They are widely used in biotechnology and in the biomedical field due to their large surface area and high level of conductivity. Gold nanoparticles in particular are stabilized with polymers and tannic acid. So gold nanoparticles have been used for centuries due to their interaction with visible light. It was discovered that they could detect toxins and pathogens. It is antibiotic, antifungal, antimicrobial when it's added into plastics, coatings, nanofibers, and textiles. It can be used in a catalyst for chemical reactions, and it's used in MRI. And so like over here, you can see the different uses that they're used for.
Afreen, can you take out the black, box? You can take it out. Black box, yeah. Take out. Yes. Thank you.
Okay.
Yeah.
So I'll give you an example of how gold nanotechnology has improved the medical fields today. So in 2007, Purdue University was able to use gold nanoparticles to detect breast cancer using photodynamic therapy. Photodynamic therapy is when light is applied to a tumor containing gold nanoparticles, and the particles rapidly heat up and it kills the tumor cells. So researchers at Worcester Polytechnic Institute are using antibodies attached to carbon nanotubes and chips to detect cancer cells in the bloodstream. The nanoparticles selectively target cancer biomarkers and cancer cells, which allows for a more sensitive diagnosis and early detection requiring minimal amount of tissue, monitoring the progress of therapy and tumor burden over time, and it only destroys the cancer cells. It also is being developed to act as molecular imaging agents, which reports on the presence of cancer-relevant genetic mutations or the functional characteristics of a tumor cell. This information can be used to choose a treatment course or alter a therapeutic plan. Gold nanoparticles have many properties that are of great value for the diagnosis and treatment of cancer tumors because they're small in size and can penetrate widely and deposit on the tumor site. They can bind to many proteins and drugs, and they have good biocompatibility. It's a lot of words, so I think explaining this diagram will make it easier to understand. So over here on the left, you can see that there is a person and labeled as the cancer tumor. This is called site-specific delivery. It's where the gold nanoparticles will carry this drug, and because they are selective biomarkers, they can detect where the tumor is, and it'll go directly to the tumor and deliver the drugs used in the chemotherapy. And so here you can see photodynamic therapy and how it's being used, which I explained is how the gold nanoparticles rapidly heat up under the infrared light and kill the tumor. So first, gold nanoparticles are inserted into the body. They go to the tumor. Once infrared is applied, they slowly heat up and it kills the tumor, and eventually the person is free of a tumor. And this is a closer look of what happens. So you can see that there are nanoparticles in the tumor, and the infrared is converting light into heat, or the nanoparticles are converting light into heat, which results in cell death. Obviously, it doesn't happen this quickly, and it isn't always effective because with everything, there are always problems, but it is a potential solution in the future that they're trying to improve even more. So in the future, they're also trying to make gold nanorods as potential vaccine carriers against infectious diseases. This one is by Russia's National University of Science and Tech, and they want to fight schistosomiasis, which is a disease that causes a lot of deaths worldwide. And so in the graphic, you can see that the darker capsules are the virus, schistosomiasis, and the lighter ones are the gold nanoparticles. And you can see in A, C, and E, eventually the gold nanoparticles are using site-specific delivery of drugs to kill off the virus, and the BDF graphs are just showing over time how the virus is low. So one more example is COVID-19, which is also affecting us very greatly right now. And they're using gold nanoparticles to do testing. So UMD School of Medicine, you can see in this diagram, they're using a nasal swab containing the test sample of the person, and it's mixed with a sample lab test containing a liquid mixed with the gold nanoparticle, and it binds to the coronavirus. So if the virus is present, you can see here that the gold nanoparticle will change the color to dark blue at the bottom, and if it's negative, then it'll remain the original color of purple. And so in the future, this originally takes like 10 minutes, but in the future they want it to take only 4. And besides COVID-19, that's just what's happening right now. They're also working on more specific targeted drug delivery, the usage of nanorobotics, and just faster processing and energy harvestation. So that's it. Thank you.
Thank you so much. Thank you. Thank you, Afrin. Questions from panel judges, please.
Hello. Thank you for your Afrin. Thank you for your nice presentation and very informative and very smart presentation. I have one question. Sometimes nanoparticle may be toxic. So how do you think that? How do you remove the toxicity of the nanoparticle if you want to use it for treatment, medical application?
Well, obviously, I'm not an expert on this, but I'm just guessing that over time, scientists and researchers will be able to work on that to make it more safe for humans to use in the medical.
Okay, one more question I can take.
Okay, I have one question. As a student of a high school, I think you should have advanced knowledge about nanotechnology, a little. Okay. My question is, why do you use nanoparticle in biological application? I mean, drug delivery or bioimaging. Why not gold bar or gold powder, quartz powder, or bulk materials instead of gold nanoparticle?
Well, specifically, gold nanoparticles are used in the biotechnology and biomedical fields because they have certain properties such as like large surface area and a high level of conductivity, and they can also detect toxins and stuff that are very like unique to them, and that's why they use that instead of other materials for that.
Okay, thank you very much. I wanted to clear your answer. That is, the biological molecules and nanoparticles have almost similar sizes. That's why gold nanoparticles matches very well with drug delivery or bioimaging, etc., etc. Thank you very much.
Thank you so much. Thank you, Afrin, for your presentation. So let's go to the next middle schooler student, Shabib Din. Shabib, are you there?
Yes. Okay. Good afternoon, everybody. My name is Shabib. I'm 11 years old. I'm rising 6th grade. I'm going to Patapsco Middle School. My science project is natural dye synthesized solar cell. The purpose of the project is to find out if pomegranate juice is a good natural dye to make a dye synthesized solar cell. To make it short, I'll say DSSC. Introduction. A solar cell is a device that can produce electricity using the power of the sun. The SSC converts sunlight to electricity using the power of dye. The SSCs are cheap and easy to make. The dyes used in the SSCs can be natural dyes such as raspberry juice, blackberry juice, or any kind of fruit juice. Natural dyes are nature friendly. The materials I used were pomegranate fruit dye, conductive glass slides, titanium dioxide, colloidal graphite or carbon paste, iodine electrolyte, and a multimeter. In this image, it shows 3 pomegranates. I extracted those pomegranates to pomegranate fruit dye. The white slide is titanium dioxide slide, the purple slide is pomegranate fruit dye slide, and the black slide is carbon paste slide. In the next slides, I will show you how to make a natural dye synthesized solar cell. Testing of conductive glass slide. I got a multimeter, I got a glass slide. I am testing if the glass slide is conductive or not. Solar cell construction. I got a conductive glass slide. I got a carbon paste. I coated the conductive glass slide with carbon paste. I dried it, and the black slide is cathode slide. After that, I got another conductive glass slide. I got a titanium dioxide paste. I coated the conductive glass slide with titanium dioxide paste. I put it in the spin coater so it spins and it becomes homogeneously smooth. I put it in the hot plate so it gets heated up. After several hours, I got it out so it can get cooled down. I soaked it with pomegranate fruit dye. For several hours. After several hours, I washed it and I left it at room temperature. So the purple slide is anode and the black slide is cathode. I put cathode and anode together like a sandwich. I put the iodine electrolyte so the electrons start circulating the device. I clipped them all together and I got a dye synthesized solar cell. Current measurements. I got a multimeter and I got my natural dye synthesized solar cell. I went to the sunlight and I measured the current. The results were 6.5 milliampere. Conclusion. A DSSC is made with a natural dye and extracted from the pomegranate fruit. The current of the DSSC was measured. Blueberry, blackberry, and other fruit juices are suitable for DSSC. Thank you for your time. Any questions?
Okay. Any question for Shabib?
Yes, I have a question.
Hi, Sahib.
I have also one later.
Lots of questions.
So my question is, Uddin Junior, you did a nice presentation. Actually, you implemented it. Now the question is very silly. So since you are taking our pomegranate juice, raspberry, blueberry, all the juices from our shelf, then how much juices you need to make your device? Otherwise, if you take too much juices, we will be out of juice. Our refrigerator will be empty juice.
You need like one specific juice. Fruit
Well,
juice.
that's the pomegranate. How much juice you need to make one cell?
Need like one juice box of pomegranate.
One juice box for one cell?
One juice.
Okay, don't take our juices, okay? Keep going, all right.
Okay, so my question is, you should know this answer. So you said you worked on dye sensitized solar cell. That means dye is sensitized. So what is the example, or what is the similarities with nature? I mean, how dye is sensitized? Do you see any similarities in nature?
Like, what do you mean?
Huh?
Like, what do you
Okay, the answer is photosynthesis. Okay, using chlorophyll, plant leaves, they produce energy, right? Okay, I think you are the youngest participant in our competition. Thank you, thank you.
No, I think one more we have later. You can see.
Hi, Doctor. Hi, Shabib.
Really?
Yeah.
Hi, Shabib. Good.
Hello.
Good. Very good presentation. Thank you.
Thank you.
I just have a quick question for you. What's so special about the pomegranate?
About the pomegranate?
Yeah. Why we choose pomegranate? Do you like it?
Like, it's my favorite. It's one of my favorite fruits.
Oh, okay. All right. And
Yeah.
it's colorful. Is that correct?
Yeah.
Yes.
Yeah, like other fruits colors are boring for me.
So can we use something like can we use other fruits like star fruit or something to make Dyson-sized solar cell as well?
Yeah.
Okay, let's try it then, right?
Mm-hmm.
Thank you, Shabib.
Okay, thank you so much, Shabib. Next speaker is our high schooler, Jareen Mahmood. Jareen?
Yes, I'm presenting.
Yes.
Okay. Good afternoon. I am Zareen Mahmood and I'm a rising 10th grader at Delaney High School. And my project is on the preeminent applications of iron nanotech and relevance in COVID-19. So this project discusses nanotechnology and nanoparticles, the types of available NPs and iron NPs in detail, followed by its multi-sectoral applications, such as that in environmental science, medicine, and in COVID-19. The project then concludes with a discussion of the importance of this type of nanotech. So nanotech and nanoparticles. So nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. 1 nanometer is a billionth of a meter. If we were to see this on a comparative scale and a marble was 1 nanometer, then 1 meter would be the size of the entire Earth. A nanoparticle, which is essentially an ultrafine unit with dimensions measured in nanometers. So this is what the diagram shows. So because of their submicroscopic size, they have unique material characteristics, and manufactured nanoparticles may find practical applications in a variety of areas. So NPs can be classified into different types of, well, according to size, morphology, physical, and chemical properties. Broken down by usage, here is an overview of the different types of NPs. So carbon-based NPs are mainly used for the structural reinforcement, as they are 100 times stronger than steel. Ceramic NPs have applications in photocatalysis, photodegradation of dyes, drug delivery, and imaging. And semiconductor NPs are used in photocatalysis, electronic devices, and photo optics, as well as water splitting applications. Polymeric NP applications include protection of drug molecules and the ability to combine therapy and imaging. Lipid-based NPs have application in the biomedical field as a drug carrier and delivery and RNA release in cancer therapy. Finally, as for metal NPs, they are prominent in research areas in the detection and imaging of biomolecules and in environmental and bioanalytical applications. So examples of this include gold, silver, and iron nanoparticles. So iron nanoparticles and its properties. So firstly, this large image shows the microscopic images of 20 nanometer iron NPs. So the nanoscale iron particles are submicrometer particles of iron metal. They are highly reactive because of their large surface area, and in the presence of oxygen and water, they rapidly oxidize to form free ions. Iron nanoparticles are spherical, or they are faceted high surface area metal nanostructured particles. So nanoscale iron particles are typically 20 to 40 nanometers with specific surface area in the 30 to 50 meters squared per gram range. So the two main forms are magnetite and its oxidized form magnetite. So magnetite has an inverse spinal structure with oxygen forming a face-centered cubic crystal system, whereas magnemite has a cubic unit cell. So these NPs display super paramagnetism, as in their magnetization is 0. What this means is that in the absence of an external magnetic field, they can be magnetized by an external magnetic source. So this property essentially provides additional stability for magnetic NPs in solutions. So synthesis and reactivity. In a nutshell, metal nanoparticles are prepared from metal precursors. So these nanoparticles can be synthesized by chemical, electrochemical, or photochemical methods. And in chemical methods, the metal nanoparticles are obtained by reducing the metal ion precursors in solution by chemical reducing agents. So iron NPs can be synthesized by the reduction of iron 2 or iron 3 salt with sodium borohydride in an aqueous or like a liquid medium. And the chemical equation on the left portrays this. And then as for reactivity, when exposed to oxygen and water, iron oxidizes or combines with the two, and the second equation shows this. So the multisectoral applications of iron NPs. So these nanoparticles have attracted considerable interest due to their super paramagnetic properties, as I said, and their potential applications, which arises from its biocompatibility and also from its non-toxicity. So essentially, there are many different sectors which can benefit from iron NPs. And just as an overview, it can be part of sciences ranging from surface sciences to semiconductor physics to even energy storage. So for example, they can serve as contrast agents for magnetic resonance imaging, which is MRI, like a scan of the brain. They can be gene carriers for gene therapy, as well as be used as magnetic sensing probes for in vitro diagnostics. They can also be used as nanoadjuvants for vaccine and antibody production. So recently, iron oxide nanoparticles have attracted much consideration, like I've said, due to their unique properties, which include super paramagnetism, surface to volume ratio, get greater surface area, and their easy separation methodology because they're easier to obtain. So now for some specific applications in the category of environmental science. Magnetic iron NPs can produce nano-based fertilizers, fungicides, and pesticides, which boost plant growth, and this is according to a PubMed article. So increased biomass can also be produced from these substances. Essentially, the article states that this strategy is safe as the process does not put NPs into the soil, and also there is reduced dose requirement as compared to other more harmful like chemical fertilizers. There are also no adverse effects on plant growth. As for environmental remediation, pollution can be prevented through detection and monitoring with the help of NPs, and wastewater treatment can be accelerated by creating permeable reactive barriers, as well as like membrane filtration. Moreover, catalyst coatings such as palladium can help with carbon capture to reduce climate change. And iron NPs also allow for improvement in energy by better distributing heat, as ceramic-like materials, as iron NPs, can provide sufficient reliability and durability of the entire structure. So the applications of these NPs in medicine are just as drastic. In the biomedical world, magnetic NPs, magnetic NPs, particularly those coated with liposomes, can be applied to drug delivery as an MRI contrast agent, and as cellular therapy, as in cell labeling, tissue repair, and purifying cell populations. In hypothermia, the property of the superparamagnetic crystal suspension can help absorb energy of an oscillating magnetic field. So the energy is converted into heat and then destroys the pathological tissue or cells. So because the tumor cells are more sensitive to high temperature, they are killed. They can also be utilized as therapeutic agents in chemotherapy and serve as nanocarriers for vaccination and antimicrobial activities. The diagram shows that iron NPs can improve many conditions such as bone marrow problems and fix issues such as iron deficiencies. There is also an area of possible applications in COVID-19, which is a disease resulting from the SARS-CoV-2 global pandemic, as we all know. So due to the current global emergency, as well as like the length it takes to develop antiviral agents and vaccines, the World Health Organization has adopted the strategy of repurposing existing medications, and iron oxide nanoparticles were previously approved by the FDA for anemia treatment. So, and then studies have also demonstrated its antiviral activity in vitro. So these, along with NPs coated in silica, which have a strong affinity for RNA, which is like the genetic material inside the virus, can play a part in the COVID-19 vaccine production. Finally, the importance of iron nanotechnology. In conclusion, so there are up to 16 different available forms and multi-sectoral benefits. Nanotech is being heralded as like the key to new cancer treatments, energy independence, as well as improved electronics and as well as like cleaning water for third world countries. So with such a diverse range of possible applications, nanotechnology has the capacity to change the world that we live in drastically. So to accomplish this feat, scientists and engineers that work on nanoscale materials still need to better understand how they work, and therefore further research is warranted. These are my references. Thank you.
Thank you so much. Okay, I'll take one question. Hello.
Thank you very much, Jillian, for your nice presentation and very informative presentation. I have one question, very simple, I think very silly question. As you mentioned that nanoparticle has the higher surface ratio. Can you explain this? Why this it has the higher surface area?
So they're really small, which can create like a higher surface area than other particles, since they take over like a larger area while also being small. So like they increase the amount of space that there is for this, for example, like in iron nanoparticles. So there's like a larger space for the magnetism to work.
Okay, so as the nanoparticle in size, this is very small, nano scale. So why the surface area is bigger? Because the size of the nanoparticle is very small. So why do you think that the surface area should be bigger?
I don't necessarily know. This was my first exposure to nanotechnology, but like I know that it has to do with like its submicroscopic properties.
Okay, we are out of time. We have to go next. Thank you so much, Jareen. Okay, next speaker, our middle schooler, Laiba Munir. Please, 8th grade. Laiba, are you there?
Yes, I'm here.
Okay.
Okay, can you see my screen?
No. Yes.
Okay.
Go ahead.
Good afternoon. My name is Laiba Munir, and I'm a rising 8th grader at Dumbarton Middle School. Today, I'm going to be presenting about nanotechnology and silver math. What is nanotechnology? According to Wikipedia, nanotechnology is defined as the particular technological goal of precisely manipulating atoms and molecules for fabrication of macro-scale products, also now referred to as molecular technology. A more generalized description of nanotechnology was subsequently established by the National Nanotechnology Initiative, which defined nanotechnology as the manipulation of matter with at least one dimension sized from 1 to 100 nanometers. Nanotechnology is technology created to manipulate atoms to change or enhance macro-scale products. The prefix nano is derived from the Greek word nanos, which means a dwarf. What's the purpose of nanotechnology? Nanotechnology invents and innovates macro-scale products, specifically by altering and manipulating the arrangements of atoms. One example of a macro-scale product is glasses. Glasses have a purpose that they fulfill very well, which is to temporarily improve eyesight. But there are also some things glasses don't do very well. They can break very easily. Both the benefits and the downsides of an object fully rely on the arrangement of its atoms. Each and every single macro-scale product is made of a specific arrangement of atoms. So what if you rearranged some of those atoms? You could make unbreakable glasses. The arrangement of atoms in a macro-scale product affects its variables, from its strength to its texture to its flammability. Nanotechnology is and has been arranging atoms to improve our everyday items, such as nanosurface protection materials, carbon nanotube armor, and band-aids. Nanosurface protection materials make use of nanomaterials to develop thin layers protecting surfaces that they're applied to. For example, NanoRepel uses a coating of pure quartz glass to strengthen surface elasticity or flexibility and resist destructive materials and temperature. Carbon nanotubes incorporated into Kevlar products, which are traditional bulletproof material, enhances the ability to prevent blunt force trauma from weapons. Finally, adding silver into band-aids is more beneficial for the prevention of bacteria. Silver obstructs the metabolism of bacteria, which disrupts its growth, and nanotechnology allows us to alter such products and introduce new aspects into them. What are some problems currently in the world that nanotechnology can solve? Inefficiency of the creation of solar cells, hydrogen use, storage and distribution, water shortage, and COVID-19. The problem I'm going to target today with my new invention idea is COVID-19, a respiratory disease that has taken over the world. It has infected over 5 million and killed over 150,000 people, and it's a current and unsolved issue. Even if one isn't as strongly affected by COVID, they can spread it to family and friends, which can be fatal for any. My idea was to introduce silver into face masks. Nanoparticles of silver would be woven into fibers, constructing a breathable silver cloth mask with the help of nanotechnology. How will this work? Silver kills germs while oxidizing and releasing silver ions, deadly to yeast, germs, fungi, bacteria, and even some viruses. And face masks are everywhere nowadays. If you go out in public, you'll notice almost everyone is wearing one. They're known to prevent disease spread and cover the mouth and nose. Why not incorporate the two into a breathable face mask with silver nanoparticles arranged and created by nanotechnology? So as you can see, this is my prototype design. It would consist of silver nanoparticles in the cloth of the mask, and there would also be a nose wire to fit to every user's nose for added protection. The silver would be used as nanoparticles, so there would be no visibility of the silver or prevention or hindering of breath.
The face mask model that the silver would be incorporated to is a non-disposable cloth mask with a nose wire. This allows for reusability. Due to the silver nanoparticles added into the mask, the protection and strength is enhanced, improved, and upgraded over other masks. The pros outweigh the cons. Some benefits of this product include enhanced respiratory protection, decrease in the risk of an infected person spreading it to others, and reusability. Some downsides of this product include silver poisoning and cost. The likelihood of getting silver poisoning from nanoparticles in a face mask is very low. We're already eating with silver utensils and wearing silver jewelry all the time. So who's to say that we're going to get silver poisoning from nanoparticles in a face mask? And cost-wise, silver is expensive, but think of how much of it we invest in other unnecessary products, such as jewelry. We can recycle the silver we have wasted in such products by melting and reusing. I'm very sure that jewelry is way less important than saving other people's lives. These are my sources. Thank you for listening.
Thank you. Question, please.
Yes, I have one question to her. Actually, these days, face masks, silver nanoparticles are used commercially because it is antibacterial. It has antibacterial effects and other bacterial virus or other medicinal applications. My question is to her, how do you want to use silver nanoparticle in mask? Just kind of painting or how?
I said that basically what would happen is that nanoparticles of silver would be woven into the fibers that construct the mask.
Okay, thank you very much.
No problem.
Okay, thank you so much, Laiba. So let's go to because we have a more speaker, so we have to go. Okay, so next is Tasin Farhad. Tasin.
Yes.
I'm very happy that still we have a lot of people are listening, their patience. I'm really, really appreciated. So we have more young scholar will talk. So please stay with us.
Are you able to see my screen?
Yeah, so take out that black box, please.
Oh, yeah. Okay.
Yeah. Yes, we can see you.
Okay, so good afternoon. My name is Tasin Farhad, and I'll be going into 11th grade at Centennial High School. And today I'll be presenting on silver nanoparticles, which will be abbreviated as AGNPs throughout the presentation, and their applications. So just as a brief outline of my presentation, first I'll be speaking about silver nanoparticles and what nanoparticles are in general and provide some background information. Then I'll be speaking about two distinct properties of the silver nanoparticles, surface plasmon resonance and antimicrobial properties. Afterwards, I'll be describing both of them and then providing applications of both. And finally, I'll be talking about the COVID-19/SARS-CoV-2 pandemic and then provide some background information about the virus and discuss possible applications of these silver nanoparticles. And then finally, I'll conclude with a conclusion and acknowledgements. So first of all, what is a nanoparticle? So a nanoparticle is just a particle on the nanoscale. And just for reference, it would be between the sizes of 1 nanometer and 100 nanometers. And just for a reference, a tennis ball is 100 million nanometers. So essentially a nanometer is 100 million times smaller than a tennis ball. And so silver nanoparticles are just nanoparticles of silver between the sizes of 1 nanometer and 100 nanometers. And like I said, these nanoparticles have two distinct properties, the surface plasmon resonance and the antimicrobial properties. And so surface plasmon resonance is when the surrounding light interacts with the surface plasmons or free electrons of the silver nanoparticles. This results in the oscillation of these surface plasmons, and this creates a strong absorption and scattering of light. So one possible application of this is in dye-sensitized solar cells. So in a dye-sensitized solar cell, we have an anode and a cathode. And then in between, we have the titanium dioxide, which holds the dye molecules, and then we have an electrolyte. So essentially what happens is that when the photon hits the dye molecules, an electron is knocked off, and then it passes through the titanium dioxide and then through the anode, and it passes through this circuit. And sometimes it goes through this external circuit, and then it probably connects to like a, for example, light bulb or cell phone, depending on what you want to use the electricity for. And then it comes back through this electron flow back into this cathode, and it passes into this electrolyte. And this triiodide ion takes this electron and passes it back to the dye, where the hole was left with the previous electron. And so this creates this large electron flow. And so recently, Coppin State University conducted an experiment which applied silver nanoparticles to dye-sensitized solar cell in an attempt to increase the solar cell efficiency. So all solar cell efficiency is the proportion of energy it is able to harvest as electricity of the total solar energy. So the results of the silver nanoparticle fabricated dye-sensitized solar cell. So the average nanoparticle size was 23 nanometers plus or minus 5.2 nanometers. And as we can see in this chart down below, the dye-sensitized solar cell with the nanoparticles yielded a much greater efficiency than the one without. So as we can see, the N719 dye is a ruthenium-based dye, and on its own, it yielded an efficiency of 0.98%. However, when we add the silver nanoparticles to it, we get an efficiency of 1.2%. And then when we add the silver nanoparticles and a third coating, which is a titanium tetrachloride, which also increases efficiency by increasing absorption of light, the efficiency increases all the way to 1.76%, nearly double what it was with just the dye. And so these results align with the hypothesis that the silver nanoparticles would increase the scattering and absorption of light and in turn increase the efficiency. And so the second property of silver nanoparticles are the antimicrobial properties of silver nanoparticles. And these antimicrobial properties are more specific to the Ag+ ions of these nanoparticles. But however, these on their own are easily sequestered, meaning that they easily react with other substances and are nullified of their antimicrobial effect. So the nanoparticles themselves provide an easy and effective delivery mechanism for these ions to the actual microbes themselves. And so the size, shape, and charge of these silver nanoparticles affects this interaction with the microbes. And also the type of microbe affects its interaction with this silver nanoparticle, because different microbes have different interactions with silver nanoparticles. And so as we can see in this graphic to the left, there's a multitude of different ways it could possibly interfere or destroy the microbe. So for example, it could attach the cell wall or cell receptors and prevent the microbe from attaching to a host cell. It could destroy the energy production, or it could also stop replication by inhibiting cell division. And so as a result of its antimicrobial properties, silver nanoparticles are already used in many everyday products, such as athletic wear, home appliances, and medical equipment. And these are all objects and things that you don't want microbes to be able to persist and build up on. And so this is where the possible application comes into COVID-19 or the SARS-CoV-2 virus. So the SARS-CoV-2 virus is a recently new coronavirus, which has completely changed the dynamic of the recent world, as we are seeing now. And so this virus is highly transmissible because it primarily transmits through the respiratory droplets. And so this is what makes this virus particularly potent, because respiratory droplets come out of our mouth whenever we breathe, cough, sneeze, laugh. And so this is why health officials encourage us to wear masks, which prevent these respiratory droplets from traveling far and possibly into other people's respiratory systems. And so the goal would be to create an antimicrobial coating which uses nanoparticles, including silver nanoparticles, which would nullify the coronavirus and like viruses. So as we know, even when we sneeze, cough, and talk, the masks, they don't completely shield the respiratory droplets from traveling outward. They only stop it from traveling outward to the extent of like 6 or 8 feet, for example. And so even when we touch our masks, also, our hands become infected with the virus if we had it. And so what happens is that these viruses still have the potential to make it all the way into public spaces, particularly public objects that we touch a lot. For example, at the gym, we might touch the weights or the treadmill, or in public workspaces, the elevators, the desks, the chairs, and also in grocery stores, for example, the conveyor belts, which is something that is very often touched by both the consumer and the employee. So the goal would be to create an antimicrobial coating that we would place on all of these different public surfaces, which would nullify this coronavirus. And the goal would be for it to break down the virus and make it inactive. So when the next person touches that surface and they accidentally touch their mouth or nose, that it doesn't give them the COVID-19 disease. And so discussions have been raised about the potential to use this in combating coronavirus, because silver nanoparticles have been effective against creating an interfering and inhibiting effect against other viruses. For example, against the dengue type 2 virus, it inhibited the production of the dengue virus envelope. And then, for example, for the rhinoviruses, it inhibited the virus replication. And for the HIV-1 virus, I believe it prevented the replication or inhibited the replication. So as we can see that the nanoparticles have a variety of different interactions with the different microbes. So we would just have to see which type of nanoparticles and which blend and hybrid of nanoparticles in particular targets the COVID-19 or the SARS-CoV-2 virus the best, and which one is able to nullify it the best. And so my conclusion in my research is that the applications of silver nanoparticles entails a large variety of possibilities. As we have seen, the surface plasma resonance helps us harvest energy better, and also the antimicrobial properties help us fight off microbes better. And so the use of nanotechnology will hopefully lead the way in fighting future pandemics and microbes. And so I would just like to acknowledge Dr. Gan and Dr. Uddin for guiding me and aiding me in my research, and Coppin State University for the materials and supplies they provided for experimentation. And here are the references that I referenced throughout my presentation.
Thank you so much, Tasin. Any question, please?
Yeah.
You're on time. Yes, please.
Yeah.
Can you speak loudly, please, Dr. Chaudhary?
Yeah. Thank you for your nice presentation, and your really very good scientist, little scientist, I can say. So my question is about the DSSC. So you are using DSSC, in DSSC you are using electrolytes. So what different types of electrolyte you can use in between anode and cathode?
So for this particular
the state of the electrolyte, is it the liquid or solid, or in between liquid or solid? What do you think?
So in particular for this experiment, they used a liquid electrolyte. So I know there's a wide variety that may be able to use, but in this particular experiment, they used a liquid one, and the results received were
Can we use
liquid.
the solid electrolyte or gel type electrolyte?
I believe that
solid.
I believe that it would be able to be used, but I think that in order for it to effectively bind, I think it would be better to use some sort of an aqueous solution.
Okay. And another question is that you are using the dye and iodine. So if you use the cell, I mean the solar cell repeatedly, is there any possibility to finish the dye that you are used in the cell?
Yeah, so this has been a widespread concern, in particular of dye-sensitized solar cell, because of their longevity. So as we know, the commercially produced ones with silicon, they are able to survive many years without any problems. And so yeah, this is an area of concern where the dye might wear off, or the effectiveness of these dye-synthesized solar cells may wear off in the long term. So yes, there is concern regarding that.
Okay, thank you so much, Tasin. So we have to go next one. Middle schooler Joshua Seether, please. Joshua?
Yes.
Yes,
One
please.
minute. Okay. Good morning. My name is Joshua Seether, and I'm a 7th grader at Loyola Blakefield.
Today, I'm going to talk to you about hydroelectric power. What is hydroelectricity? Hydroelectric energy is a form of energy that harnesses the power of water in motion. An example of that is a waterfall, which a picture on the right side is showing that's generating electricity. Hydropower is a renewable source of energy, and it accounts for about 96% of renewable energy in the United States. Some advantages are that it does not use resources to create electricity, and it does not pollute the air, land, or water as other power plants may. Some parts of a hydroelectric power plant. Some parts is the dam, which controls the flow of water and creates a reservoir of water. The penstock, which is pipe channeling water from the dam to the turbines, and turbines are large blades that are moved by the water, and the generator is parts connected to the turbine that create electricity by moving large magnets, also known as electromagnets. Transmission lines transport energy to places where it's needed, like your homes. How is the energy produced? A hydraulic turbine converts the energy of flowing water into mechanical energy. A hydroelectric generator converts the mechanical energy into electricity. The principle was discovered by Michael Faraday. He found that when a magnet is moved past a conductor, electricity flows. Electromagnets are made by circulating direct current through loops of wire wound around stacks of magnetic steel laminations. When the rotor turns, it causes electromagnets to move past the conductors, causing the electricity to flow and the voltage to develop at the generator output terminals. Some types of hydroelectric power plants are impoundment, which is the most common type, and it uses a dam to store river water. Another type is diversion, and in this, a facility channels a portion of a river through a canal. This does not use a dam. And pump storage stores electricity for later use, and this stores energy by pumping water uphill when the demand is low. Here's a picture on the bottom right of when the demand is high, like in the day, the water goes down through the plant. When the demand is low, like at night, the water goes back up and up the plant. And this reuses the same water over and over again. The potential of hydroelectricity is that it's a clean and safe energy source. It's self-sustaining, and it can actually help control flooding. And this is very efficient, ranging from 90 to 95%. This can help improve environments for fish because they have fish ladders, and fish ladders can help salmon find their spawning ground. Also, no fossil fuels are burnt in the process. Also, hydropower plants are flexible because when the demand is low, they can reduce the water flow. Some fun facts are that Niagara Falls has a hydropower plant, and it's called the Robert Moses Hydroelectric Generating Plant. Here's a picture of it on the right side. And this supplies 1/4 of all the power used in Ontario and New York. Hydroelectricity is one of the oldest power sources on the planet. It was actually once used by farmers in ancient Greece for mechanical tasks like grinding grain. Also, Washington State uses their electricity, 70% of their electricity comes from hydropower, causing it to have lower bills than most other states. Conclusions. Hydroelectric energy is renewable. We will always have a substantial amount of water. Hydropower could create thousands of new jobs for building dams and the machinery. But using hydroelectricity, we can have a cleaner environment with less greenhouse gases. And it's economically sustainable because it can help lower electricity bills. Here are some of the sources I used. Thank you.
Okay, Joshua, thank you. I'll take one question. Anybody, please? Judges.
Yeah, Joshua. What do you think the downside of your hydroelectric power generating system? What is the downside?
Some downsides are that it can be expensive and difficult to build a dam, and in the rare possibility of a very large drought, then it wouldn't, like, the water, there wouldn't be much water.
Okay, good.
Okay, thank you so much. So thank you so much, Joshua. Next speaker for a high school student, Omar Ostruk. Omar?
Yes, I'm
Omar, are you
here.
there?
Yes,
Okay.
I'm here.
Good.
Can I have a moment to share?
Yes, please. Here you go.
Can you see it?
Yes.
Yes, please. Go ahead.
Okay. So my name is Omar Osterk. I am going into 10th grade and I am at Eastern Technical High School. And my presentation is about hydrogen fuel, the future of fuel for humanity. What is hydrogen fuel? Hydrogen fuel is a new and innovative idea for clean energy that has already been tested in commercial products. It is abundant in many places and can be reused over time. How does it work? Hydrogen is gathered through hydrolysis and sent to fuel stations via truck. Hydrolysis is the process of taking solar or any other type of energy and putting it into water to separate the oxygen from the hydrogen, and then the hydrogen is stored and then later transported to stations similar to gas stations, but instead they store hydrogen. So after they are stored, cars and other appliances can use hydrogen fuel cells that do the opposite reaction of hydrolysis, converting hydrogen and oxygen into water and producing energy in the process. So the hydrogen fuel cell, it has 3 membranes in the middle. One of the membranes is a polymer electrode membrane, otherwise known as a PEM, and this one is the one that is right in the middle and takes oxygen and hydrogen and converts it back into water and creates electricity in the process. And the other 2 membranes on each side, they take oxygen on one side and hydrogen on the other, and they ionize the molecules and cause them to be able to bond. What are the benefits of hydrogen electricity? It is very efficient when compared to other clean energy sources such as solar and wind. As hydrogen electricity, the electricity is created inside of the vehicle instead of having to be transported from solar cells or a wind turbine. And a hydrogen-powered car can travel up to 1,000 miles with a fuel tank, compared to gas and biofuel, which are other types of chemically stored energy, producing types of energy that hydrogen fuel is much more efficient than them. Why is it better than other renewable energy sources? Although solar power has less steps of getting energy from source to machine, as it only needs a solar cell and a converter to be able to convert DC to AC, it cannot store electricity as well as hydrogen, as batteries are not very expensive, but they're more expensive than having a storage silo for hydrogen, like a tank. So, and also wind energy not only takes up large amounts of space, they hurt surrounding wildlife by knocking bats and birds out of the air. It's the same with all 3 types of electricity that people are looking at today. Solar energy, wind energy, and hydro energy, like with water, they all produce electricity instead of producing chemical products such as biofuel or hydrogen, and this causes them to not be able to store it as easily because electricity is not as easy to store as actual physical compounds. What are some disadvantages? As hydrogen energy is relatively a relatively new item to the market, customers are still reluctant to eagerly purchase it. The concept of an alternative and almost perfect energy source would be most likely cold-shouldered by multimillionaire fossil fuel energy companies, as they would want to keep their companies going and keep getting money. Past knowledge of hydrogen's combustible properties, catastrophes such as the Hindenburg, make citizens dubious of the safety of hydrogen fuel. Although hydrogen fuel it does use hydrogen, which is very, very flammable, it is in a very closed and safe and secure system, and it's nothing like the Hindenburg, which would actually fill a large amount of space with hydrogen gas, while the hydrogen fuel cells do not fill a large amount of area with hydrogen gas, and that is easily flammable, and instead puts it in a closed circuit to be combined with oxygen into water and therefore become harmless. Real-life examples of hydrogen power. Today, many popular car brands such as Hyundai and Toyota are using hydrogen fuel cells to power their cars, and they are very efficient. And although they are not commercially available as much as other like gas-powered cars and even Teslas and other electricity-powered cars, they have been shown to be greatly beneficial towards the environment and to the user of the car. In the near future, larger hydrogen cells could be put near homes to supply an enormous amount of power and heat. Summary: hydrogen is clean and bountiful. Hydrogen is a clean and bountiful energy source with many benefits. It will no doubt pass humanity's energy need tests with flying colors. Thank you.
Okay, thank you, Omar. Okay, question and answer, please. Judges.
I have a question, Omar.
Yes. Yes.
It's great presentation. I just want to ask you, like, how visible you see, like the hydrogen, the hydrogen cell get more application other than used for cars. I know currently it's used for the Tesla car and for others, but so we basically making energy cell from water. Yes.
Yes.
Do you have you read anything like recently about the development of this energy reactor, like from water reactor itself?
Yes. The process of hydrolysis has actually been developed many years ago and has been used in used not in many like electricity products, but more in like scientific research. The hydrogen fuel cell, people are thinking of using it as an electricity generator for homes and other living areas. The hydrogen fuel cell, it would take in a slightly more amount of hydrogen and oxygen and convert it into way more energy than a hydrogen fuel cell inside of a car would. And of course the only byproduct is water.
Thank
you.
Okay,
take one more question. Yes, Dr. Chaudhary.
It's really very exciting technology to use hydrogen for our electricity production. But I have one question, that you showed that using the sunlight you can split the water. So what is the mechanism? I mean, you have some water and you are putting the sunlight, you have sunlight unlimited. So is it possible to split water to get the hydrogen using only the sunlight, or you need Scientists
are developing new ways to to start the process of hydrolysis, which converts water into hydrogen and oxygen. But right now, the most efficient way is to use electricity, which can be produced by many different methods and other renewable energies to make a more amount of energy using hydrogen. But yes, and researchers are developing new ways to use just sunlight to cause hydrolysis to take effect.
So what things you need to split the water except the in presence of sunlight?
It's actually very simple. You put a current into water and it causes the water to
Okay,
split
you are
into
not using
hydrogen.
current, you are using the sunlight. You are using
Yes,
the
yes.
sunlight and water. So what other things you need to split the water to get the hydrogen?
Oh yes. So you would need some kind of converter to convert the sunlight not into electricity, but maybe even heat, because it's still a new subject, but researchers are finding ways to use not only sunlight, but maybe heat and other forms
you
of
need
energy.
the materials, which is called the photocatalyst.
Oh, the materials. The materials. Yes. The materials would probably be silicon and other types of silicon and some types of conductive metals, such as aluminum and iron and copper.
Okay, thank you so much. Okay, I know that this is really going on very nice. We have a lot of people still here. We are out of time, but still we have to go a few more. I really appreciate it. Thanks for your patience, please. We are almost there. Okay, let's go to the middle schooler, Abif Ali. Abif? Abif, are you there?
Yes.
Yes, okay. Oh my God. Okay. Abif is 6th grader. Go ahead, Abif. Yep.
This is my project about renewable energy. This is the pros, cons, and facts. What's renewable energy? Renewable energy is a type of clean power production. It is more environmentally friendly than other energy types. Types of renewable energy: solar energy, wind energy, hydroelectric energy, and biomass energy. What are solar panels? Solar energy are a type of renewable energy that uses the sunlight to produce energy. How does solar energy work? The silicon in solar panels absorb the sunlight to produce energy. What happens in a smaller scale is that the photons of light hit the atoms of the solar panels. This movement frees the electrons inside the atom, which creates the electricity. The pros and cons of the solar energy. Pros. Solar panels usually last 25 to 35 years. The cost of solar has lowered 70% in the past decade. Solar energy does not pollute as much as coal and oil. Solar energy can make money and profit. The payback for cons. The payback for solar energy is around 7.5 years. Some roofing types make solar energy installation more difficult or costly. Buying solar panels up front is expensive. What is hydroelectric energy? Hydroelectricity is made by generators getting pushed by water. Hydroelectricity is usually made by dams to push a large body of water to create a reservoir. The reservoir collects water, then releases the water, which uses the pressure behind the dam, which leads the water to a turbine. And this is how it works. The pros and cons of hydroelectric energy. The pros: hydroelectricity is more constant than other types of renewable energies. Once a dam is running, the costs are low. Hydroelectric dams are more safe than other types of energy. Hydroelectricity is more efficient than other types of energy. Cons: building dams can disrupt the environment because large lines and wire have to be built. Dam locations are not easy to find, and most dam locations are taken. Building dams are extremely expensive and takes years to build. Facts about hydroelectric energy. Around 20% of the world's hydroelectricity is gathered by hydroelectricity. By using hydroelectric energy, the world saves 22 billion gallons of oil per year. Hydroelectric energy is the highest provider of renewable energy. In the US, only 2,400 out of 80,000 dams are being used for hydroelectric energy. What is wind energy? Wind energy is the process that uses wind to make energy. How does wind energy work? Windmills work by using wind to make energy. Wind turns the blades of a windmill, which spins a shaft connected to the generator, making energy. The pros and cons of wind energy. Pros. Wind energy does not produce harmful gas emissions. Operating costs and wind energy are very low. Wind turbines don't take up a lot of space, so you can build farms where the turbines are. Cons. Wind doesn't always come, so the turbines don't spin 24/7. Wind turbines can kill birds and bats that fly into them. Conclusion. In conclusion, you have covered that renewable energy have many pros and cons. In many ways, renewable energy is improving humanity in several ways. These are the sources.
Thank you, Aviv. One question for Aviv, please.
Hey, what is it?
Did you finish or not yet? Did you finish your presentation?
Yeah.
Aviv?
Yeah.
Okay, good. So one question, anybody?
Yes, I can ask one question. Yes. This is really appreciating a small kid how fluently has explained total energy production systems. This is renewable energy, all parts, solar cell, then windmill, then other sources. My question is, what is the benefit of renewable energy over existing fossil fuels? Do you understand what is the benefit of using renewable energy?
Yes.
What is this?
Huh?
Why renewable energy is better? What is the advantage of renewable energy?
Renewable energy is better than fossil fuels because it's more clean and there's more renewable energy than fossil fuels.
Clean, just clean.
No, not so there is more.
Okay, anyway, thank you very much.
Okay, so let's go to the next presenter for high school student, Rauza Bari. You're almost there, be patient.
Good afternoon, my honorable judges. My name is Rauza Bari. I'm writing 9th grade, and I'm from Western School of Technology and Environmental Science. Today, I'll present renewable energy, and the topic that I choose is hydroelectricity. What is hydroelectricity? Hydroelectricity is a form of energy that harnesses the power of water in motion. It's produced by hydropower. In this picture, you can see this dam which produces hydroelectricity. How it operates. This diagram shows how hydroelectricity operates. The reservoir is a large collection of water which makes potential energy. Then it goes to the dam where it holds the water in a man-made lake or reservoir behind it. The turbine is where it converts the energy of flowing water into mechanical energy, like they convert it. The generator converts the mechanical energy into electricity. The powerhouse is where the both pipe and penstoke feed. At last, the transformer is where it converts the alternative voltage and where it transmits the electricity to other places. There are some benefits of hydroelectricity. It is environmentally friendly. That means it doesn't cause any harm to the environment like fossil fuel does. It's a renewable source. That means it doesn't run out. It is reliable and efficient. It is safe. There isn't any harm. It is fundamental vehicle for development. So hydroelectricity is a new and better way to produce electricity. Though there are some benefits of hydroelectricity, there are some disadvantages about it. It displaces people. Hydroelectric dam can take a lot of space and so people have to move. It could cause droughts. Hydroelectric dam can take a lot of water. It is expensive. Hydroelectric dam has a lot of part and you have to pay for it and it will take a long time to make it, like a lot of years. And there are limited reservoirs. Not all places have a reservoir. Hydroelectricity impacts the environment by affecting land use, home and natural habitat in dam area. That means it is hard for the people and animals who live close to these dam area. I'm now going to show 4 hydroelectric dams in the US. Over there, that's the Grand Coulee Dam located in Grand Coulee, Washington State. This is the Hoover Dam, like one of the big dams in the US. It is located in Nevada. This is the Raccoon Mountain Dam located in Tennessee. And this one over there is the Dallas Dam located in Oregon. Hydroelectricity is a renewable source and doesn't run out. Despite the cons of hydroelectricity, the pros are stronger. It doesn't cause any pollution and it is safe. I believe hydroelectricity is more efficient and we should choose hydroelectricity. Thank you for watching.
Thank you so much. So question for Rauja, please. Judges. No question?
Okay, Raja. Just a quick question. You know that in science or research, you need to have, let's say we explained very well how the hydroelectricity works and what are required, what the pros and cons and all this. You are a high schooler and you know that in research, you need to have a problem question, right? Here is a problem and here I am Raja. I am proposing this solution for this new problem. Okay, think that way in future presentations. And it's not a question, just a comment for you.
Thank you so much. Thank you, Rauja. You tried your best.
You're welcome.
Okay, next presenter is Nafif Ali, 9th grade.
Hello.
Yes. Loud your presentation.
This is my slides about nanotechnology. My name is Nafif Ali, and I'm currently in ninth grade. This is the table of contents of this slide, and this is what's going to be in it. Nanotechnology is about the changing or manipulation of small particles in the scale of atoms or molecules, and it's measured of the unit of nanos. Nanos are the size of 1/1000th of a meter. How are nanoparticles?
We cannot see your. Excuse me.
Huh?
Nafif, we cannot see your slide.
You can't see my slides?
Yes.
Is it fine now?
No.
Just keep on. What is going on?
His research is not published yet. He does not want to make it public, right?
Yeah. Okay. You just try. I have to go because of time. I have to go another person. In the meantime, you try, please. Rafi Mirza, can you go out, please? Rafi?
Yes.
Yes, please. Rafi, in the meantime, you try.
Okay. Can you see the screen?
Yes.
Okay. Hi, everyone. My name is Rafi Mirza. I'm a 12th grader at Chesapeake Science Point. And my project is about gold nanoparticles, traditional novel approaches, as well as applications. So what is nanotechnology? It's the study and applications of materials at a molecular level. The concept was first theorized by Richard Feynman at a Caltech lecture in 1959, and the term was properly coined by Norio Taniguchi in 1974. So when I describe just how small nano is to people, there's a few fun examples I like to use. So there's about 75,000 nanometers in a single strand of hair, 100,000 nanometers in a single sheet of paper, and the human fingernail grows at about 1 nanometer every second. So what are specifically gold nanoparticles? They are microscopic particles of gold that are generally in a colloidal suspension in water or other fluids. They can range from 5 nanometers to 400 nanometers, and each size can yield certain properties. Though gold nanoparticles are often associated with a spherical shape, they can also come in the size of a triangle, cube, or rod. And their color ranges from a ruby red to a deep purple. So the image on the bottom left shows the color possibilities, and the image on the right shows both spherical gold nanoparticles as well as gold nanorods under transmission electron microscope image. So how are gold nanoparticles traditionally synthesized? So when I did my research at the Koppen lab, the protocol I used called for 2 solutions. One was a gold salt solution, which required 0.1 grams of gold salt and was diluted with certain amounts of water. Another was the sodium citrate solution, which called for 2.5 grams of trisodium citrate dihydrate, and was also diluted with a certain amount of distilled water. So for my protocol, I brought the gold salt solution to a hot plate, and once it began to boil, I added in 2 milliliters of the sodium citrate solution via micropipette. So after I added in the sodium citrate, it would go through a color change over a 20-minute interval and would end in deep purple color. So the reason we add the sodium citrate solution is because it's a reducing agent and a stabilizing agent. So a reducing agent is something that loses electrons, and a stabilizing agent is something that essentially like stabilizes or balances the reaction, like the name implies, and it allows for the nanoparticle shape to actually form. So this is like very critical for the formation of the particle. But how else can they be made? Through a green synthesis. What is a green synthesis? It's actually a biosynthesis, and it's a much more energy and environmentally efficient method. So there's many drawbacks to traditional gold nanoparticle syntheses. So a biosynthesis is becoming very important. So in a biosynthesis, there are specific macromolecules and cellular structures that are used to form nanoparticles. One of the most popular ones are materials that have antioxidants in them because they allow for this reducing agent reaction. So one way I'll cover is a biosynthesis via an aloe vera leaf extract. So aloe vera is a very, very common medicinal plant, and it's popular for things like relieving sunburn and wound inflammation. So gold nanoparticles can be biosynthesized using aloe vera as leaf extracts. So in the protocol I researched, the leaf extracts were soaked in deionized water, crushed using mortar and pestle, boiled, and then placed in a centrifuge to be separated. And then they were used in according proportions to synthesize the gold nanoparticles. Another protocol I looked at was using biosynthesizing gold nanoparticles via bacteria. And obviously there's many, many types of bacteria that you can use. But the one I looked into was called D. radiourans, and it's often used for this process where it's aerobically grown in yeast, placed in a centrifuge, and then resuspended in the yeast and then mixed with the gold solution. And this will similarly yield gold nanoparticles. Making gold nanoparticles is great, whether it be through traditional or novel synthesis, but what can they actually be used for in the real world? So gold nanoparticles can be used as cancer contrast agents. So contrast imaging is essential for diagnosing cancer because it allows us to highlight the location of certain tumors. And gold nanoparticles can be used as a more effective contrast agent compared to iodine because they are more accessible, they're more easily penetrated by light. So the image on the bottom, the images A, B, C, D show gold nanoparticles as contrast agents in rats. And EFGH shows iodine as contrast agents. And as you can see, the top images where gold nanoparticles are used, they are much clearer and much better than the iodine pictures. So ultimately, if we can implement gold nanoparticles in cancer imaging, it can really help to contribute to the fight to defeat cancer. So like many other people already covered, gold nanoparticles can also be used in COVID-19 detection. And it's a pandemic that's affected millions of people around the world, and there's still places where efficient screening systems are unavailable. So researchers at the University of Maryland School of Medicine have discovered a way to use gold nanoparticles to quickly detect COVID-19 in under 10 minutes. So after a patient uses a nasal swab or they spit into a container, the RNA is extracted using a combination of a highly specific molecule paired with gold nanoparticles that target a protein that is associated with COVID-19. So if the patient is positive, then the solution will turn blue and it will be visible to the naked eye, which is very, very useful because it will lead to greater efficiency and cost effectiveness. So gold nanoparticles can also be used in solar energy. So fossil fuel-based energy, as many people have already also spoken about, is detrimental to our planet. And solar energy is a very promising source during this crisis. However, it's held back because in some aspects it's inefficient. So we can use gold nanoparticles in solar cells because they have high surface plasmon resonance. And if they're placed in the polymer layer of a solar cell, they can scatter light much more efficiently and create much more solar energy because of their, like I said before, their ease of penetration by light. So gold nanoparticles can also be used in food and drug testing. So one of the most common problems, particularly amongst like Muslim populations, is that there's poor contamination within food products that we don't even know about. So gold nanoparticles can be paired with a DNA biosensor to detect compounds associated with pork and make it easier to separate those items which have been contaminated. So beyond just pork contamination, we can also use gold nanoparticles to detect like proteins or compounds that people are allergic to, such as like lactase. And that if we implement this, it could really save millions of lives without us even knowing it. So how do I actually plan to use gold nanoparticles in the future? So this past fall in 2019, I completed a project at the Koppen lab where I used a method of inelastic light scattering called Raman spectroscopy to detect specific chemical bonds associated with breast cancer cells, which I developed. So gold nanoparticles can impact my research as well, in that it can enhance the ability to detect these bonds and reveal new correlations within malignant cells that may not be currently known. So this process is called surface enhanced Raman spectroscopy. So I'd place a substrate of gold nanoparticles under my breast cancer cell sample, and it could reveal new correlations and new bonds that are present in malignant and benign cells that I may not be currently aware of. So the image on the bottom left shows one of the graphs I worked with for my project last fall. And the image on the right, specifically the orange graph, shows what SIRS can do to something without a SIRS substrate. So as you can see, it reveals a lot more information that can be very valuable to my research. So with all this new data, I can strengthen the machine learning algorithm I already wrote and create a much more sophisticated and accurate detection system to detect cancer. This is my bibliography. That concludes my project. Thank you so much for your time.
Thank you so much. Thank you so much, Rafi. Is there any question, please?
I have a question. Hi, Rafi. At the last of your presentation, you brought a term. You want to use machine learning algorithm in your this. So can you highlight a little bit which machine learning algorithm you are aiming to use here?
We can't hear you. We can't hear you. Can you please repeat again?
No, it's okay. I heard the question.
Okay.
Yeah. So I actually already wrote the machine learning algorithm. That was for my project last fall, and I used it was a pretty basic decision tree model, which looks at a specific point on the Raman graph, and if it's higher or lower, it'll go down continuously, be categorized until the computer can accurately say whether it's a malignant, benign, or a test sample cell. So that's called a decision tree. So with the SIRS, if I have more data points, I can use several decision tree models to make a random forest model, and that would create more like efficiency and accuracy in my detection system in categorization.
Okay, good luck with your research.
Thank you.
Thank you so much, Rafi. Okay, let's go with the Nafif. Nafif, are you ready?
Okay, I'll try again with this. It's like every time I press it to present, it just closes out immediately.
Okay, actually, I can't help you. I don't know that because you see, we have to finish. So you can talk, without your slide presentation. I don't know.
My slides is about nanotechnology, and And nanotechnology is changing or manipulation of small particles in the scale of atoms or molecules, and it's measured in the unit of nanos. Nanos are the size of 1/1000th of a meter. Nanoparticles are made and found in laboratories or factories, and it can be found in the wild from biological matter like viruses and other small organisms. It can be found in the wild from volcanic ashes, magma, ocean, and fine sand or dust. And the difference between the man-made nanoparticles and the natural nanoparticles is that the natural ones are more odd and different shaped, and the man-made ones are like more have more uses, and it's similar to other made. It's made and it's made multiple of. And there's three metallic types of nanoparticles: iron, silver, and gold. And silver nanoparticles can be used to make nanowires, plastics. It can deliver drugs to your body and separate cells or repair them. Silver nanoparticles can be used in medical cases like chemotherapy, and it can be used in cosmetics like paints or dresses, and it can be used to help make fuel cells. And gold nanoparticles it can be used for electrical conductors and sensory probes, and it can be used as medical uses like with cancer and delivering drug. But if used wrong, it can be toxic to your body. Nanotechnology can be used to clean the air, but because gold nanoparticles can help detect any toxic things in the air and absorb it, and nanotechnology can also help purify water using something called nanofiltration, which is a filtering method that uses 1 to 10 nanometers long holes that can separate water from contaminants or other dangerous materials like bacteria, viruses, and this purify water in waste management or just normal home tap water. And they can be used to help gather energy, like it can be used to make like in solar energy can be used to make more efficient cells and make the silicons take in more sun and turn it into electricity more efficiently, and they can be used to make fuel cells by making the use of materials like platinum more effective, or they can just replace different expensive materials like with silver nanoparticles to make fuel cells more cheaper and more accessible, and have a better energy consumption. But in conclusion, the nanotechnology can be helpful to humanity in multiple ways, such as making and manufacturing more easier, help in medical cases, clean the environment, and produce our energy more efficient. Nanotechnology has its cons, but the pros outweigh it, and nanotechnology can be improved and more greatly in the future.
Okay, thank you. Thank you so much. Yes, one question I can, if you have, I know that you have a problem to show your slides, but you tried. Any question? Okay, any? No. Okay, thank you so much, Nafif. I'm sorry, you have a question? Okay, go ahead, Dr. Chaudhary.
Okay, no problem. I think you are presenting. You have presented very nice. No problem. You are not able to show the screen. Okay, so do you think that what is the difference between the molecule and nanoparticle? Is the molecule a nanoparticle? Or
No, it's just a size, like a size comparison, like molecules can be used.
Okay, no problem. Thank you.
Okay,
You
okay,
tried.
no
Because of time, we have to go. So we are almost done. So one more, I would like to tell you that their parents asked me, request me. He's a 5th grader. He's not a competitor, but I would like to we'd like to listen his PowerPoint presentation. Samit, are you with me?
Yeah.
Yes, go ahead, Samit.
Okay.
So he's a presenter. He's a 5th grader. Just, you know, he want to present. Okay, go ahead. Show your presentation.
Okay, this is my presentation. Wind, a renewable source of energy, by me, Samid Rahman. I am in Carroll Manor Elementary and I am going to 5th grade this next school year.
Where are you at? I didn't see your, you know, your camera is on?
No, my camera isn't on. My camera isn't on.
Yes, try. We want to see you.
I can't turn my camera on. It says
okay, no problem. Just go ahead.
Okay. What exactly is wind? According to the National Center for Atmospheric Research, wind is moving air and is caused by differences in air pressure within our atmosphere. Air under high pressure moves towards areas of low pressure. The greater the difference in pressure, the faster the air flows. Wind, as we can see from the above definition, is moving air, and that moving air is caused by differences in the air pressure within the Earth's atmosphere. What can wind do? One of the main things that wind can do to help us is creating energy. The way that wind turns into energy is that the turbine captures the wind's energy and turns it into mechanical energy. After that, the mechanical energy rotates an internal shaft that is connected to a gearbox, increasing the rotation by 100. In turn, the rotation of the blades creates energy. The first image up top shows what a wind turbine looks like. The second image shows what it looks like from the inside. Why wind can be renewable energy? The wind is a renewable energy because it can produce electricity. It is always available as a gift of nature. So even if we use quite a lot of the wind for energy, there will still be more replacing that wind that we took. Why is wind environmentally friendly? It is environmentally friendly because it comes from the atmosphere. When producing energy, it does not cause pollution by giving off harmful gases as fossil fuels do. Fossil fuels, on the other hand, release gases into the air that are not good and causes pollution, and fossil fuels can run out. Why should we use renewable energy? We should use renewable energy because it will be here forever, and most of them do not hurt the environment. It helps to conserve other natural resources. It can also produce affordable electricity. What were wind turbines like in the past? Wind turbines in the past were called windmills. They were mainly used for grinding grains and pumping water. The top left picture shows how a wind turbine looked in the past. The bottom left picture shows how wind turbines currently look. Some well-known wind power plants. Atla Wind Energy Center's location is in California, USA. Their annual net output is 3,179 gigawatts. Shepherd's Flat Wind Farm in Oregon, USA's annual net output is 1,677 gigawatts. Roscoe Wind Farm in Texas, USA's annual net output is 2,174 gigawatts. Bundle Wind Farm's location is in Tamil Nadu in India, and their annual net output is unknown, at least to me. Fun facts. Wind is one of the fastest growing types of renewable energy. Wind energy causes minimal pollution. It is also very affordable to mass produce. Wind is the flow of gases. Depending on their strength, winds can be called different things like gales or breezes. bibliography here, links to the websites I used to get my information. And thank you for your time.
Thank you so much. Okay.
I have a question for Samir.
Okay. Go ahead. One
Samir,
question.
You know who is smarter than the 5th grader? Nobody, right? You are the smartest.
Okay, you are the guy. Yes.
Yeah. So question is, so your wind turbine spins in one way if the wind in one.
Excuse me, I can't hear you.
Sorry?
I can't hear you.
You can't?
No.
Okay, something is wrong then. Then you are responding me already.
I can hear you now, but I couldn't hear you.
Okay. Let me ask the question again. Your wind turbine spins in one way if the air flows in one way, right? In one direction.
Right.
What happens to your turbine if the air flows in the opposite direction?
That I forgot to research.
Okay.
About that.
Okay, do the research. Let's see what happens.
No problem. Thank you so much. So thanks for you. Thank you so much. So we are done with our middle school and high school student presentation. I just got somebody's result. I would really like to help you guys.
Dr. Rubin, I didn't go yet.
Oh, who is that?
This is Tahmid Sheikh.
Tahmid Sheikh, you didn't send your presentation and you didn't tell me anything.
I sent the presentation to the email. Here, let me pull it up.
Today?
Not
What
today.
time?
I think about like a week ago.
Oh, we didn't get that. Okay, so let's take your okay. Let's go with that. Okay, we'll listen to your presentation.
Sure. All right.
Okay.
Hold up. Let me just present it real quick.
We didn't get your yes. Anyway, somehow, no problem.
All right. Is it? I'm so sorry. It's taking a little bit.
Which grade? Middle school or high school?
I'm in high school.
Okay.
Okay. It should work now. Okay. Hello, my name is Tahmid Sheikh. My presentation is on nanotechnology within agriculture and specifically the use of iron nanoparticles and its application. So what is nanotechnology? This innovative field is the future of engineering, science, and technology. Nanotechnology is the application and manipulation of matter and technology on a nano level. So basically, as a reference, there are 25.4 million nanometers in 1 inch. The average person already encounters nanotechnology in a range of everyday consumer products, such as nanoparticles of silver, which are used to develop antimicrobial properties in hand washes, bandages, and socks, or the use of zinc or titanium nanoparticles, which are active UV protective elements in modern sunscreens. So we see that nanotechnology is such a vast field and it's so innovative and it's the future of the industry, really. So the current state of agriculture is that 11% of the world is undernourished, 9% of the world population are severely food insecure, and around 1 in 4 people globally are moderately or severely food insecure. So these numbers are increasing daily, and with the current global pandemic, we see that these numbers are actually being exacerbated and they have a severe impact on the livelihood of hundreds of millions worldwide. So how can we use nanotechnology in agriculture? Research has shown that nanotechnology can be used as fertilizers and can help improve the yields of plants. We also see that they actually increase the efficiency and they're more cost effective than using regular fertilizers that have a negative impact on the environment. Furthermore, considering that nanotechnology is such a vast and innovative field, nanotechnology is one of the most crucial advancements in human history. So iron nanoparticles are what we use specifically in agriculture to, use as a fertilizer and help improve yield. The properties is that it's strong, ductile, and malleable, it's thermal resistant, and it has a high surface area. But most importantly, it's non-toxic in nature, and it's highly reactive with oxygen and water. And these come in handy with agriculture. So the scientific evidence shows that research under the Department of Horticulture at Sam Higginbotham University of Agriculture, they actually conducted an experiment where they used iron oxide and zinc nanoparticles to on carrots, and the results came out that there was a 48% increase in grain yield, and that there was a more stronger and more productive plant. Amongst another study in 2019, sufficient evidence concludes that in a lab experiment, the use of iron nanoparticle increases yield as well as efficiency. So here is a diagram showing that, by putting the nanoparticles in the soil, it acts as a soil application in a fertilizer, which in return increases yield and the growth of the plant. So this is the chemical structure of iron and how iron oxide nanoparticles will deconstruct into the soil and add multiple elements which are helpful to the nourishment and livelihood of the plant. So the synopsis and relevance of this shows that, altogether nanotechnology is such a vast field that, we should probably be giving more funding and research to, especially because it can solve one of the world's biggest problems, such as the food scarcity and global food crisis. So that's one of the biggest challenges within agricultural nanotechnology. But additionally, there's not enough research that comes to a conclusive answer, and there's not enough real-world examples that show that iron oxide nanoparticles can, on a global level, provide more food, which is why we need to increase research in agricultural nanotechnology. Thank you very much, and here's my
scientific thank you. Thank you so much. Finally, you made it. Okay, no problem, even though I missed your presentation. So any question, please? Judges. So please, those who are high school judges, please include his name, Tamid Sheikh, please. So yeah, and judge. And then any question? Judges.
Hello. Thank you. His name is Tahmid Sheikh.
Yeah.
Okay, Tahmid Sheikh. It's a very informative presentation.
Thank you.
I would like to know, to prepare the nanoparticle, okay, you have the iron oxide, right?
Yeah.
Iron oxide molecule, and also iron oxide nanoparticle. So what's the difference between iron oxide molecule and the nanoparticle?
The nanoparticle actually is the iron oxide. So it's just iron oxide breaking down onto a molecular level, which uses nanoparticles. So basically, by using iron oxide nanoparticles, it's small enough that the surface area actually increases the yield and acts as a fertilizer.
So why not iron oxide? Only iron oxide is not the nanoparticle.
So if you use iron oxide just regularly, it's too big, and the soil doesn't absorb it. So one of the properties of iron oxide as a nanoparticle is that it's highly reactive with water and oxygen. But if you use regular iron oxide, it doesn't react as well.
So you mean that in iron oxide nanoparticle there are lots of iron oxide molecule, right?
Yeah.
Okay, thank you so much. So here, let's end up this session. So William, I know that we are out of time, but it's very interesting topics, and we have 12 high school students presented. and 9, 10 middle school and 1 elementary school student presented. So I know that long day, long hours. I really appreciate it. I would like to now go. William, are you there? So you have you see that in the it will be short. William, go ahead. What do you want to do? And in the meantime, judges, please send me your results to email me. Some of them already I got, so please send me. Okay, William.
Dr. Uden and everyone, good afternoon. And I just want to say that all students did a wonderful job. This is Dr. Dotson here at Coppin State University, and I will be facilitating the quiz for the middle school students. So all middle school students.
Okay, all middle school. Go ahead.
Yes, all middle school students. Head to joinmyquiz.com and enter the code as you see here. I see a couple students have started, and I'll give it another minute or so for everyone to actually start. And then I'll hand it over to Dr. Gan for the high school students and the guests.
Give me a little bit more time to them. Those who are middle school student, please enter this code and then your name to, yes, go ahead. I want to see more. Give a little bit more time, 1 or 2 minutes, please.
Okay.
So it will be fun game, only fun quiz. You will love it. I know that you are bored, but thanks for your patience. Go ahead, those who are in this, I can see that. Please register your name with the code for play this game, quizzes, only for middle school student. I can see more and more. And then we'll start after that, high school student, when you finish. This is easy, but you have to wait for your oral presentation results because you see I have to collect it. Let's see how that will go. So all the judges in the meantime, while they play, please give me your feedback, your evaluation to me, and then I'll request somebody to put it together. So it will take time. Is there any more middle school student?
I think we can start now with the middle school.
Good. Go. Where is that? William, what happened?
Yeah, because they are done. I'm now going to the high school student.
Oh, they are working now?
Yeah, so middle school are working now.
Yeah.
And
very good. Go ahead in the high school. So it's good. Those who are high school judges, please send your score.
Can you see my screen?
Yes. For high school student, William?
Yeah, so high school student.
Okay, please enter everybody high school student.
We'll have one for the guests too. So if you are not a high school student, you are not a middle school student, don't worry, I'll have one for you. But high school student, go ahead and sign in.
Okay, giving more
Do
time.
we have
little
any
bit.
more high school students? All right, so already, how to start?
So I can talk, William, while they're
Yeah.
doing. Okay, Dr. Chaudhary, I'll send you the mail to all of high schools result. And Dr. Sobi, will you volunteer to calculate?
Okay.
Dr. Udin?
Yes.
Yeah. I just sent you all the evaluation.
Yeah. I saw that. Just 1 second. Let them do the quizzes. I'm looking the everybody.
Okay,
So,
Dr. Uddin, I have sent.
yes, I got it. So let me send you, Dr. Faisal Chaudhary. I am sending you the result
Okay,
for every high school.
Yes,
The
I'm
judges.
waiting for you.
Yeah, please. So, William, are they working? William. So, Dr. Chaudhary, I'm sending one.
Yes, I'm waiting, but
Okay, I'm sending one. Monish Sarkar, please give your. Okay, Dr. Raj.
Yeah, I am working on that.
You're working on that. Dr. Raj working. Dr. Fred. Dr. Fred is giving already.
Yes, I sent mine already.
Yes, I got it. I'm forwarding. So,
yes, I got one.
so you'll get one more soon. And Dr. Sobi, can I send all of them? Can you help me out to calculate? Dr. Sobi?
Yes, is those the middle school?
Yeah. Can I send everybody's?
Send me the middle school, yes.
Okay.
I send you actually middle school. Yes.
Okay, yes. Keep your one, and I'm sending middle school for other people, okay?
Okay.
Okay. I'm going to send Emmanuel one. So I sent one, Dr. Sobi.
Yes.
And
Dr. Udin, if you can send me the list of the students, updated list of the students, if you have it or William have it, can you send it to me?
Okay. I'm sending 2 people already. Now third person, third judges. So Dr. Stoby, you can see the four of them, four judges' results are there,
Okay.
including you five.
Okay, so 5 with me. Okay.
Yes.
Okay. Great. Thank you.
Thank you so much for your help.
Absolutely.
Please calculate and then, yeah, for every, there are 9 presenters. I'm sending the list.
Thank
Dr. Stoby, I'm sending the list, yeah.
Okay.
Dr. Chaudhary, wait for another 2% still working. Meantime, you can work, please.
I just sent you mine.
Thank you so much. I'll send it to Dr. Chaudhary. 1, 2,
All right.
5, 6, 7. Dr. Sobi, we have a 9%. So I'm sending the.
Okay. You send me the names.
Copy. So yes, I'm sending right now.
Okay. Thank you.
Yeah. Dr. Udin, can you hear
Yes.
me? As you
I'm sending an.
One.
Yeah.
The first one, there is a missing of number of
Number 12.
one.
Yes, Tasbik Sheikh. I'll put it name. Just wait.
Hanna. No. The Hanna.
Hannah, just 1 second.
The missing. The sheet is there, but no score is there.
Really? My here.
I say 35. Document number.
Just
35.
wait. Yeah, Hannah Seeter is there. In the high school student. Okay, Dr. Sobi, I sent it to you. Dr. Chaudhary, I'm sending another person data. Dr. Monish Sarkar.
Yes, I just got it.
Yeah.
Thank you.
Please.
Thank you.
Dr. Chaudhary.
Yes.
So you put the first judges. There are 4 or 5 judges.
Yes. Okay. I will do.
Yeah, please do that one. Yeah, that's fine. Dr. Sarkar, I didn't get your mail. Can you send it again, please? Dr. Monish Sarkar, please.
Yes. Surely. Let me try.
I didn't get that. Dr. Chaudhary, we are waiting for 2%. Dr. Raj and Dr. Sharkar, Dr. Munir Sharkar. So we'll send it while they're complete. And Dr. Sobi, are you okay?
Yeah, Dr. Udin, the one that you send me that has scores on it. Who's this? Whose judge is this?
Oh, who is that?
You send me one list that have some scores. Which judge is it?
See that down there, there is a name. I just forwarded to you.
Yeah, there is no name on it. You just said the scores.
Okay, just let me check.
Okay.
Is it Faiza Sadmim? No. Or Dayan? Dayan sent. No. Dayan is okay. Samiul Azam, let's see. Oh, he put the score directly.
Who's this? Yeah, which one is this, Dr. Udin?
Samiul Azam. Dr. Samiul Azam.
Okay.
Samiol.
Yes. Yeah.
Thank you, Dr. Raj.
I
So I'm sending to Dr. Chaudhary, Dr. Raj result. Let me send Dr. Chaudhary, just wait. Forward. Chaudhary. Yes, I'm sending the Dr. Raj, Dr. Chaudhary. Now we are waiting. Dr. Munir Sharkar, could you please send me again?
I am sending again right now.
Yeah, please. I don't know why I didn't get it.
Dr. Chaudhary, Dr. Uddin.
Yes.
There are 1, 2, 3 are missing from first image.
Arun Shah. So don't take that one then. Then use other people's result. Okay. So he because he was telling me that he had some meeting, so he didn't complete.
Please check, Dr. Uddin. I just sent you again.
Okay. William, they are still working?
The high school students are done, and then the
okay. Good. Somehow, Dr. Munir Sharkar, now I got it. Good. Yeah. Okay, I am forwarding Dr. Chaudhary, Dr. Munir Sharkar results.
It should say the final one, because I did not include Tahmid last week.
Yeah, you have to put it, please.
I did.
Okay, okay. Thank you so much.
Just look at this if it is the final
one.
Yeah.
So, high school judges, make sure that we have a 12 number student that Tamid Sheikh need to be in the list. He need to be judges.
Okay, so we are done with the trivia for the high school students. The first person is Uma Azdak, and second
no,
is
no. Just wait a minute. Announcement you can do it later little bit. Okay. You want to so then speak loudly. Okay, go ahead. Say it again. Okay, so we are you are giving the results for trivia quizzes for high school and middle school students. Okay, go ahead, William. Speak
so
loudly.
this is for high school students.
Yeah, go ahead.
So the first person was Omar Uzdek, and second position was taken by Zarin Mahmoud, and third is Tahsin Farhad. So they are
okay, so first one is Omar Ostruk, second one is Jareen Mahmoud, and third one is Tahsin Farhad. Congratulations to you guys. I think it was competitive, William.
Yep.
Very close score, everybody.
Okay, so the middle school.
Yeah. Go ahead.
So here are the results for the middle school.
No.
Number 1 spot goes to Efren. Number 2 spot goes to Abif. And number 3 goes to Nabiha Rahim.
Could you please again announce?
So this is the score results for the middle schoolers.
Okay.
The first spot goes to Efren. The second spot goes to Abif. And number 3 goes to Nabiha Rahim.
Yeah, please write it down, William, all of them, and then send it to me, first, second, third. Congratulations, you guys. It was so quick. So result is there, huh? Yeah, you can show the results for high school. And is it high school or middle school?
I'm still working in the.
No problem. Please take your time. I know that.
In the middle school.
No, we are publishing the quizzes result, Dr. Sobi. William, can you show the results for quizzes? Can you show? Then everybody can take a look. So those who compete in the PowerPoint presentation, I mean oral presentation, everybody will get the certificate for presenter. And those who not presented but participate, they will go to the participation certificate. Also, I would like to thank you, all the judges, those who really helped us, support us for judging the students. They will get also certificate for judges. So I will send those. Maybe it will take few days through PDF, through your email. And also let's wait for first, second, third prize for oral presentation. Our judges are working. I know that it's a very long day, but still, you see that 70 people are there, so I'm really happy. So in the meantime, I don't know that while they are working, Dr. Elhagan is with us. Dr. Elhagan?
No, he's not with us right now.
No, he's not with us. Okay, no problem. Okay, let's take some comments. Is there anybody make comments or feedback from parent side Is there anybody? Please. I'm opening floor for you. While they're working for results, please, if you have any comments, you can just unmute and talk, or you can put the comments or feedback in your chat box, please. We need your feedback. And I'm very happy that you guys passionately, all these 5 hours almost, yeah, 1 to 5 almost. Really appreciate it for your big support. Without your support, we cannot do this event. And I'm happy that some of our judges are all the way another country, and it's almost in the morning in that country, still they're awake for us. I really appreciate it for your support.
Dr. Udine,
yeah.
Dr. Elegant sends his apologies. He's in a meeting with the president right now, so he's not able to reach me in the call.
It's okay, no problem. Thank you so much. Yeah, we are getting a lot of comments, a lot of feedback, but I really appreciate it for all of our students. Patient, this is really wonderful. Is there any comments from judges besides not questioning or feedback?
Yes, I have some comments because
yes,
I have experience of evaluating undergrad, middle school and high school students in our country, that is Children's Science Congress. In Bangladesh, everywhere, maybe there is echo. Would you please fix it?
I'm sorry?
There is some echoing.
Oh, it's okay. Now fine?
Yes, now it's okay. Okay, so I'm really happy to see students, especially 6th grade, 7th grade, 8th grade students. They are presenting so nicely. And this is very much appreciating that our children are thinking about the renewable energy. They are very much concerned about the future energy resource, because fossil fuels will be ended up very soon. We may continue up to 15 years or 100 years, but later what we will do? They are very much concerned about it. This is very much appreciating, and their presentation is really very nice. I thank all of them. Thank you.
Dr. Udine, I had to mute you due to the echo, so you can unmute yourself. Can't hear you, you're still muted.
Mr. Udine, you should unmute your microphone.
Oh, I'm sorry because of that. Okay. Yeah. So I'm getting a lot of feedback. Everybody is sending a lot of comments. So this is really, really wonderful. You can see also in the chat box. Yeah. So this is our first time actually, to do this kind of virtual. But I think until now we did good. Hopefully you will agree with me. And and by this thing that maybe in near future we'll continue to do maybe face-to-face and virtual. We can do that, maybe 2 of them together. So what other comments? No parents, no anybody? Dr. Nesbitt, are you there?
Yes, I'm here.
Any comments, Dr. Nesbitt?
Yes, I'm really enjoying this event. It's really nice, even though we had to do things a little different because of COVID-19. It did not stop us, and the presentations were very, very good. Look like each time they're getting better and better. We look like we're having younger and younger students participate, and you know that's good. That's the future. They're the ones that will be solving the problem in a few more years that we're facing now. So this is really, really nice. I really enjoy it. Thank you, Dr. organizing this for us, William, and all the rest.
Thank you so much, Dr. Nesbitt, our chemistry professor at Coppin State University. Thanks, William. You sent the quizzes result. They already know. So those who got the first, second, third, they have a prizes, of course. So we'll contact you. We'll send you through by mail your gift.
Will be done in about 5 minutes.
No problem, Dr. Sobi. I know. I really appreciate it. Dr. Chaudhary is working hard too for high school. And I want both of you to announce, because you are working hard. So lots of comments and feedback we are getting. This is really wonderful. Ms. Kelly, I really appreciated for your long
Well, Harper and I have been on the call the whole time, kind of monitoring.
Thank you. I really appreciate. I should tell, especially Dr. Elagan, that you did a wonderful job. Really, I really appreciate it. Even though we are out of time, but you know, it was very interesting topics. Kids are, wonderful. Yeah, we are waiting on, everybody's waiting for the result, I know. And what other else? Oh, by the way, I would like to tell you that when, hopefully coming days will be good. Let's hope for the best. So we'd like to, love to see you guys to work face to face in our center, near future. And you'll be surprised that some of the high school students worked in our center last few years. They had their own papers as a co-author. We published by their name, also as well as our undergraduate student from Coppin, those who worked. So it's a good exposure for high school and middle school student to work in such a wonderful, research center. So you are always welcome. You can contact with me or Dr. William Gunn. So you can work. And hopefully this virtual conference will at least, it's a good exposure for, I think, everybody, those who registered here. You're done?
I got only 4. Total 4 judges.
Okay, no problem. Whatever you got, that is what we got. Yeah. So if you're ready and Dr. Sobi is ready, you can just let me know. Then you can announce. From your high school side and Dr. Sobi's side, then of course you will send your result to me, all of you. I already got the trivia result, quizzes result. So I have to keep in record. So I would like to tell all the presenters, you guys really awesome. As some of judges already mentioned, you did a wonderful job. Believe me, trust yourself and work hard. And of course, we'd like to get more. We tried, William and I, we tried more, African American student or other ethnicity to come and work. Hopefully, we'll have more student from African American students we'll get. We are trying our best. William, can you tell about that issue a little bit? Because our dean was asking why African American students are not participated here. Can you please?
Oh yeah, but the announcement was sent to the entire university community, and then we had it on Facebook and other places. So we tried to advertise and try to talk to people, but we didn't get a lot of African Americans registered.
Well, this is not a forum to discuss that. We'll discuss this next. Thank you.
Okay, no problem. I'm pretty sure this kind of program will help us definitely to spread everywhere that what we are doing, what is our activities at COPIN. So our COPIN, especially research center, is open for high school student, middle school student, of course, grad and undergraduate students as well. So there are every year, as William mentioned, last few years we have a lot of undergraduate students worked, and then they have papers, and they graduated from our university. They are in different schools, colleges, grad school or med school. They're doing very good. Sometimes they sent us mail. Few of them already got the postdoctoral fellowship. So this is a good thing. I'm sure that some of my colleagues are here with me. They are a student also in the different places, doing research in federal lab, also different company, biotech company, also they are doing PhD. So this is good for us, as Dr. Charles also mentioned in his speech.
Dr. Dean?
Yes.
Yeah, middle school is ready.
Wonderful. Okay, let's go with the Dr. Sogi. Please announce.
Okay.
So I think let me hold you. I think, as I told you, every presenter did well. So yeah, go ahead, Dr. Sogi.
It's going to be scored as first, second, and third.
Yes, first, second, third. And if they want to know anybody, their score, I can definitely I can give everybody's score.
Yes. Only first, second, third, right?
Yes. Now is the first, second, third to.
So we're going to be going with the third, the first, like the first one I'm announcing is the third place.
Okay, third place.
Okay, third place is Laiba Munir.
Laiba,
congratulations.
Okay.
From Dumbarton Middle School.
Yes, congratulations.
Congratulations. Here. Second place was Rodoshi Barry.
Okay, Rodoshi Barry.
Congratulations,
Rodoshi Barry.
And final and first place for middle school. It came from Nabiha Rahim.
Nabiha Rahim.
Nabiha Rahim.
Congratulations, Nabiha.
East Side Middle School, New York.
New York. So first place is Nabiha Rahim. Second place is, who is that?
Second place, Dr. Udin is. Second place is I have to go back to the screen. The second place is Rodoshi.
Oh, Rodoshi Bari. I'm sorry, Rodoshi Bari. And third place is
Rodoshi Bari from Brook Magnet Middle School.
That's the second place.
That is the second place. And the first place, the number one, is Nabiha Rahim, East Side Middle School in New York. Dr. Udin? Can you hear me?
Dr. Udin, we muted you because we're getting the echo from your mic when people are speaking, so you'll have to unmute yourself.
Yeah, Udin, nobody can hear you.
Okay, can you repeat again, please, first, second, third?
Okay, for middle school presenters. The third place is Labia Munir, Dumbarton Middle School. And she's an eighth grader. Second place is Rodashi Berry from Sudbrook Magnet Middle School. And the first place for middle school is Nabiha Rahim from East Side Middle School in New York. Congratulations.
Okay,
thank you very much.
Yes, thank you, Dr. Sobi. Yeah, thank you so. So, okay, so middle school. Then now, Dr. Chaudhary.
Yeah. Yes, I have made already. So can I declare?
Yes, please.
Okay, actually, all or most of the participants did very well, and their score is very close to each other. So I think all are very good performer. But we have to choose only 3. So it's not that who are not in these 3 didn't. They also did very well. So now I would like to declare the third position.
Okay.
This is Tasnim Farhad, Centennial High School, 11th grade.
Okay.
And her score is 64.25. So name is third place is
Tasnim is he.
Tasin,
I'm sorry.
Tasin Further. Sorry, Tasin Farhad.
Yeah.
Tasin Farhad is third position.
Okay.
His position is third. So now second position is Hannah Sitar.
Hannah Sitar.
Mercy High School, 11th grade. Hannah Sitar. Her score is 64.75. Very close, 64.75. She is second position. Hannah Sitar. So now I am going to declare the first position. So the name is Rafi Mirza. Rafi Mirza.
Okay. Thank you so much, Dr. Chaudhary.
66.3.
Okay, Dr. Chaudhary, thank you so much. Once again, I'm going to announce again for high school student. First is Rafi Mirza. Second is Hannah Sitar. Third is Tasin Farhad. Congratulations, all 3 of you. And the middle school presenter. First is Nabia Rohim. Second is Rodoshi Bari. Third is Laiba Moni. Congratulations, all of you. And Dr. Chaudhary and Dr. Sobi, would you please send everybody's score?
Yes.
So, once again, Dr. Charles, are you there?
Dr. Udin. You got it, Dr. Udin.
Thank you so much. Dr. Charles, are you there? No?
I'm sorry, I was talking to myself. Yes, I'm here.
Yeah, Dr. Charles, thank you so much for all the time you're with us. Can you please put a conclusion or concluding talk, if you have few words, please?
Yeah, no, thank you so much for the opportunity. Listen, I want to congratulate all the faculty and teachers that work with the students to get to this point. And I want to congratulate each student. I mean, the presentations were awesome. And I say that as someone who has been in higher education for more than 25 years and also work in a lot of grants, a lot of higher education grants with K through 12 students. So I know the quality of work that high school and middle school students produce. And I have to tell you that every student to the young man who didn't have the presentation, who did a great job, you all did well. One of the things that I was impressed with is that, it's not easy to present in front of people, much less virtual. But most of you, almost all of you had a composure, and those who got rattled, at least you got recomposed and you presented quite well. So I just want to congratulate you all for doing a great job. This is a great program. Thanks a lot.
Thank you, Dr. Charles, for all the time here with me. I really, really highly appreciate it. Thank you.
You're welcome. You're welcome.
Thank you, Dr. We'll talk later, Dr. Charles.
Yeah,
and
okay.
I would like to thank you, Dr. Charles. Actually, all our department professors, they're working hard, and I would like to thank especially all the way Asian country. You see, now is the what time you're there, Dr. Rabbani and Dr. Chaudhary? What time?
It's 3:30.
3:30.
3:30.
Wow, you could go straight to the cricket oval.
3:30 a.m.
AM.
Not PM.
So after 1 hour, the sun will rises.
Yep. Thanks a lot, guys.
But we enjoyed much.
We enjoyed it. We enjoyed very much.
Dr. Udin, you're muted.
Sorry, let's wrap up. And then you'll have a wonderful evening and wonderful good morning to all the way in Bangladesh or India somewhere. So we'll do again, as I told you, face-to-face. This is STEM Day program as well as virtual one. So we need your feedback, your your support to success this kind of event. And yes.
So how about taking one picture? I mean, screenshot. You are muted. We can't hear you.
Oh, William or Miss Kelly, did you take the picture?
I didn't, but we did. This is recorded, so we have that.
Oh, okay.
Yeah, it's recorded.
This is recorded. You'll get the.
Put it on YouTube and provide Dr. Udin with the link that he can send to everyone.
Yeah. Okay.
Thank you.
Thank you so much. Thank you so much, all of you. Let's wrap up and goodbye, all. Thank you.
Thank you.
Thank you so much. Thank you. Thank you.
Bye. Thank you, Dr. Udin.
Bye. Thank you.